Picture the Earth, not as we know it today, but as it was in the beginning. A planet shrouded in molten fire, where oceans boiled under a sun far harsher than the one we see now. For millions of years, silence was the only ruler, broken only by the thunder of volcanoes and the endless crash of waves against newborn continents. Slowly, the world cooled. Mountains rose and were ground down again by storms. Continents drifted across a restless sea. The air filled with the first whispers of life, tiny, fragile, yet unrelenting. Out of that silence came forests, oceans teeming with creatures, and eventually, the great reign of reptiles, then mammals. But in this vast span of deep time, humanity is a flicker. If Earth's history were written as a single 24-hour day, our story would not appear until the final few seconds before midnight. And so, we must ask, are we truly the first, or are we only the latest? Mainstream science tells us that Homo sapiens, our species, emerged roughly 300,000 years ago. In geological terms, that is an instant, a heartbeat. Civilizations, with their cities, writing, and monuments, appeared only in the last 10,000 years. Everything we call history, the rise of Mesopotamia, the pyramids of Egypt, the empires of Greece and Rome, all of it sits like a thin layer of dust upon the mountain of time. Yet in myths and mysteries scattered across the globe, whispers of other ages endure. Civilizations lost, peoples erased, entire epochs forgotten. Consider this. Earth is 4.5 billion years old. If advanced life can emerge in only a few 100,000 years, how many cycles of rise and fall could fit within such a staggering timeline? What if humanity, as we know it, is not the first version to walk these lands, but only the most recent? The thought lingers like an echo. How much could have been built, and how much could have been erased? Imagine a civilization rising tens of millions of years ago. Its cities built not of concrete or glass, but of substances long since ground to dust by glaciers, swallowed by shifting seas, or buried beneath layers of rock. Time is a relentless eraser. The works of even our modern world, left untouched, would vanish within 100,000 years. Skyscrapers collapsing to rust, plastics dissolving, satellites falling from orbit and vanishing into the soil. Within a million years, little more than scattered bones and faint scars on the land would remain. Within 10 million years, perhaps nothing at all. And so the forgotten dawn hangs before us, a curtain we cannot pierce. Science gives us one version of the story clear, rational, built from bones and stones. But mystery offers another, that others may have come before us, reaching heights we cannot imagine, only to vanish in the sweep of geological time. The Earth remembers in ways we do not. Fossilized forests entombed in stone, oceans layered with the skeletons of forgotten creatures, entire mountain ranges made from the sediments of vanished seas. Yet even this grand archive may not preserve the traces of civilizations like our own. For the deeper we look, the more the evidence is erased, recycled, buried. This is why the first question in our journey must be asked. What if humanity is only the latest chapter in a much older book? What if our story is not one of beginnings, but of returns? The forgotten dawn sets the stage. Ahead lies the official story, the narrative told in textbooks and museums, the tale of modern humans rising from the African savannas and building their world step by step. But even within this narrative, cracks begin to appear. Fossils where they should not exist, tools older than their layers, and myths passed down through generations that whisper of ages lost to fire, water, and time. As we move forward, we leave the silence of the dawn behind. The story of us begins. After the silence of the forgotten dawn, the official story begins. It is the version told in classrooms and printed in textbooks, the tale drawn from bones, stones, and fragments of fire-blackened earth. According to this account, our species Homo sapiens emerged in Africa roughly 300,000 years ago. They were not the first to walk upright, nor the first to wield tools, but they were the ones who would carry the spark of survival into the modern age. The earliest sapiens lived as hunter-gatherers. Small groups moved across savannas and forests, following the migrations of animals, gathering seeds, roots, and fruit. Their homes were temporary shelters of wood and hide. Their art was etched into caves, painted with ochre and ash. For tens of thousands of years, this was the human story, slow, patient, bound to the rhythms of nature. From Africa, they spread outward. Some walked across the Sinai and into the Middle East. Others followed coastlines, pushing into Asia and eventually into Australia by boat. Later waves moved north into Europe, where they encountered the Neanderthals' cousins in both form and mind. Still others crossed the frozen land bridge into the Americas, populating a new world with fire, tools, and memory. By 100,000 years ago, humans were scattered across the continents, their presence faint but growing. They had yet to build cities or kingdoms, but they carried stories and firelight into every corner of the earth. For nearly all of this time, life remained simple. Survival was everything. Generations lived and died without writing, without monuments, without machines. Humanity was clever, but still fragile, still vulnerable to the teeth of predators and the shift of seasons. Then came a change, a slow, steady shift that would alter the course of history. Around 12,000 years ago, as the last ice age loosened its grip, the climate softened. Forests spread, rivers swelled, and fertile soil appeared in the valleys. For the first time, humans settled. They planted seeds, tamed animals, and learned to harvest the earth itself. Agriculture was born. In Mesopotamia, between the Tigris and Euphrates, the first cities rose, mud brick walls shimmering in the desert sun. Writing emerged as symbols pressed into clay. Kings, priests, and merchants organized life into patterns of trade and power. The story of civilization had begun. Meanwhile, in the Nile Valley, farmers grew wheat and barley along the fertile floodplains. Generations later, pyramids would pierce the horizon, monuments not only to rulers, but to humanity's newfound mastery of stone, labor, and time. Far to the east, in the Indus Valley, cities with paved streets and complex drainage appeared, quietly flourishing, and then fading into dust. Across the oceans, the first great societies of the Americas cultivated maize and built ceremonial centers aligned with the stars. Within just a few thousand years, a blink in geological time, humanity had leapt from scattered bands of hunters to empires. Ships carried explorers across seas. Scripts recorded memory in scrolls and books. Armies conquered, temples rose, and knowledge spread like fire through dry grass. This official story is one of linear progression. From primitive caves to farming villages, from villages to cities, and from cities to nations. Step by step, humanity climbed a ladder of advancement, each rung resting on the one below. It is also a story of triumph, how a fragile species survived storms and predators, learned to shape the world, and claimed dominion over every landscape. In this narrative, there is no forgotten dawn, no hidden cycle of civilizations. There is only the steady rise of humans from the edge of extinction to the architects of the modern world. Science supports this vision. Radiocarbon dating, genetic studies, and archaeological layers all suggest that complex societies arose only recently. Nothing older than 12,000 years points to advanced cities or machines. Bones and artifacts tell a tale of gradual evolution, of trial and error, of progress measured in millennia. It is a comforting narrative, neat and complete, but it is also fragile, because as the evidence grows, so too do the questions. The footprints at Latoli in Tanzania look human, yet they are over 3.5 million years old. The jawbone in Ethiopia, dating back nearly 3 million years, suggests something strikingly familiar. In caves across Europe, art appears suddenly intricate, symbolic, and hauntingly modern long before cities rose. These details may fit within the accepted framework, but they also hint at something else, that the story may not be as linear as we believe. For even within the official version, mysteries remain unsolved. Why did humans leap forward so suddenly? Why did complex culture and symbolic thought erupt seemingly out of nowhere? And why do so many myths spread across continents and separated by oceans speak of ages before our own? The mainstream narrative is clear, orderly, and widely accepted. But cracks have begun to show. Cracks that lead us into shadows where science hesitates and where mystery takes root. And so, as the chapter of the official story closes, another begins. Fossils and stones appear where they should not, suggesting lives lived in times long before the accepted record. These anomalies whisper to us from the earth itself, hinting that the past may be far stranger than the story we've been told. The story of humanity, as told by science, is meant to be precise. Fossils are the bookmarks of time. Layers of rock preserve the sequence of life, each stratum a chapter, each fossil a word. The deeper one digs, the older the record should be. Orderly, predictable, clean, and yet there are pages where the words do not fit. In 2015, deep in the Afar region of Ethiopia, scientists uncovered a fragment of jawbone, weathered but unmistakable. Teeth arranged in a line that looked strikingly familiar. It belonged, they concluded, to an early member of our genus Homo, and it was dated at nearly 2.8 million years old. That is hundreds of thousands of years earlier than expected. The discovery pushed back the timeline of humanity's origin. It did not erase the official story, but it unsettled it. For if a human ancestor walked the African plains so long ago, what else might have walked beside them, lost to history, unrecorded, and unimagined? This was not the first anomaly. Half a century earlier, in Tanzania, researchers found something even stranger. On a plain of ancient volcanic ash, hardened like cement, were a series of footprints. They were delicate, arched, and hauntingly human. Later analysis placed them at 3.6 million years old. But according to the accepted timeline, humans did not yet exist. These tracks were attributed to Australopithecus afarensis, the species of the famous fossil Lucy. And yet, when seen in the stone, the impressions resemble the footprints of a modern person walking barefoot across a beach. The question lingers: how could creatures thought to be primitive leave traces so eerily similar to our own? In Mexico, in the Valsequillo Basin, reports emerged in the 1960s of human-like footprints pressed into volcanic ash that was more than 40,000 years old. Some claims even suggested ages stretching into millions of years. The findings were dismissed, disputed, and in many cases ridiculed. The evidence was said to be misinterpreted or the layers disturbed. Yet the whispers of those discoveries never truly vanished. Further north, in Kentucky, miners once reported finding human-like footprints embedded in coal seams dated to hundreds of millions of years ago. Mainstream science rejected the idea outright fossilization does not preserve such things without extraordinary conditions. But the accounts, written down and preserved in old newspapers, remain as odd echoes of an unsettling possibility. Even in Europe, strange finds emerge. In the early 20th century, workers quarrying limestone in Nevada discovered what appeared to be a fossilized sandal print, complete with a faint impression of stitching. The rock that held it was dated at over 300 million years old. Such discoveries are controversial, often dismissed as natural formations or misinterpretations. And yet, each one gnaws at the edges of certainty. The logic of geology insists that these anomalies cannot be real, that layers of rock and sediment mark the passage of time with precision, that no human or anything resembling human could have walked the earth so deep in the past. But if even one of these anomalies is genuine, then the timeline is not what we believe it to be. Consider this: the earth has remade itself countless times. Seas have risen and fallen. Mountains have been ground down and built anew. Whole continents have shifted positions like slow-moving rafts upon the mantle. Civilizations, even advanced ones, could vanish in such cycles. Their remains crushed, melted, and rebared far beyond recognition. The fossil record is vast, but it is also fragile. Bones decay, wood dissolves. Only under rare conditions does anything survive. What if the remains of earlier beings, earlier humans, or human-like species were lost to these immense geological erasers? And what if the few traces that remain are dismissed because they do not fit the framework we expect? Odd facts linger in the margins of science. Tools found in strata too old to hold them. Objects that seem crafted by human hands, yet encased in stone long before Homo sapiens ever walked the earth. Each case may be explainable. Each may be dismissed. But taken together, they form a chorus of quiet contradictions. The footprints at Latoli, the jawbone in Ethiopia, the disputed impressions in Mexico, the whispered accounts of fossilized shoes and tools. They do not rewrite the story, but they do suggest that the book of humanity has missing chapters, pages torn out, earned, or left unread. Mainstream science is cautious. It must be. Extraordinary claims demand extraordinary evidence. Yet history reminds us that what is dismissed in one age is often reconsidered in another. There was a time when the idea of continents drifting across the earth was ridiculed. A time when meteorites were laughed off as fantasy. A time when dinosaurs were seen as impossible. Perhaps the same will one day be true of humanity's own deep history. Meanwhile, myths from every culture continue to speak of forgotten ages. They tell of worlds before this one, of people erased by floods, fires, and storms. They describe not a straight line of progress, but a cycle, a rise, a fall, and a return. As the fossil record whispers of footprints and bones that do not belong, myths offer another voice, echoing the same possibility, that we are not the first, but only the latest to walk upon this ancient stage. And so, we turn from the stones themselves to the stories preserved in memory. Stories that have survived the fires of time, passed from lips to parchment, and from parchment to our own imaginations. Stories that may hold, hidden within metaphor, the faint memory of the first people. Stone remembers in silence, but memory also lingers in story past, from elder to child, from generation to generation, until it weaves itself into myth. Where the fossil record falters, legends endure. And across the world, from deserts to mountains, from islands to frozen tundras, these myths whisper the same refrain: we are not the first. In Mesopotamia, the land between the rivers, ancient Sumerians recorded on clay tablets the tale of gods who shaped humanity. The Anunnaki, they were called, beings who descended from the heavens, who ruled over the first cities, and who walked among mortals as kings. The tablets speak of a time before the flood, when rulers reigned for tens of thousands of years, their lifespan stretching beyond anything natural. Then, as if by decree, the cycle ended in deluge. Civilization began again, smaller, humbler, yet always shadowed by what came before. Far across the ocean, among the Hopi people of the American Southwest, stories are told of worlds before this one. They speak of the first world, destroyed by fire, the second, washed away by ice, the third, broken by floods. And now we live in the fourth world, fragile and temporary, awaiting its own renewal. These are not stories of a single beginning, but of countless beginnings, each erased and begun anew. In Hindu cosmology, time is not linear but cyclical, turning endlessly through yugas, great ages of rising and falling virtue. Humanity, it is said, has lived through golden ages of wisdom and dark ages of ignorance, each cycle collapsing and restarting over spans of millions of years. Gods and demons battle in the heavens, and humans below mirror the same eternal struggle. The cycle never ends. It only repeats. The Maya of Central America told of successive creations, each world destroyed when it fell short of divine design. In the Popol Vuh, the sacred text of the Keishi people, the gods first made men of mud, but they crumbled away. Then men of wood, who lacked souls, and so were washed into oblivion. Only the third attempt, with flesh fashioned from maize, gave birth to the ancestors of the Maya. But even this was not the first. Creation only the first to survive. Among the Dogon of Mali, myths tell of beings called the Namo, who came from the stars, bringing knowledge of agriculture and astronomy. For centuries, anthropologists dismissed these tales as symbolic. Yet the Dogon described the existence of Sirius B, a faint companion star invisible to the naked, long before modern telescopes confirmed it. Did memory preserve something more than metaphor? In Polynesia, on remote islands scattered like stepping stones across the Pacific, stories describe waves of ancestors who came before, only to vanish beneath rising seas. Some speak of a lost homeland swallowed by the ocean, others of gods who withdrew their favor, leaving people to begin again on smaller shores. And in Norse myth, a similar rhythm resounds. The gods themselves are fated to fall in Ragnarok, the twilight of the world, when fire and ice consume the earth. Yet even then, from the ashes, new gods will arise, and humanity will be reborn. Across continents, across languages, the pattern is the same. Not one creation, but many. Not one humanity, but cycles of humanity. Each erased, each renewed. Are these myths only metaphors, poetic reflections of floods, famines, and natural disasters? Or are they fragments of memory, carried across the ages by those who survived? Consider how stories work. They are more resilient than stone, more enduring than parchment. They shift and change, but at their core, they preserve truth. A great flood may become the wrath of gods. A falling star may become the spear of a celestial warrior. Yet beneath the symbolism lies an event and memory too important to forget. In nearly every culture on Earth, there is a flood myth. From the Epic of Gilgamesh to the biblical tale of Noah, from the Aztec story of Coxcox to the traditions of tribes in Australia and China. The theme repeats. A great deluge swept across the world, destroying all but a few. Always, there are survivors who begin again. Always, civilization is reborn. Why should such a story be universal? Why should people separated by oceans, continents, and millennia all preserve the same tale? Science points to the end of the Ice Age, when glaciers melted and seas rose more than 100 meters, drowning coastlines where early humans once lived. Myth remembers it as flood, but the myths go further. They speak not just of one flood, but of many destructions, of fire falling from the skies, of winters that lasted for ages, of stars that shifted their places in the heavens. These are not the memories of one generation, but of cycles echoing through deep time. If myths preserve memory, then they suggest something profound, that civilizations may have risen and fallen long before our recorded history began. That humanity, or something like humanity, may have walked this path before, only to vanish beneath the weight of catastrophe. It is here, in the tension between science and story, that the possibility emerges most vividly. Fossils hint at anomalies, bones in the wrong layers. Myths add another voice telling us not of one beginning, but of many. As the Sumerian king lists stretch back thousands of years before the flood, as the Hopi remember worlds erased. As the Hindu texts speak of cycles measured in millions of years, we are left with the question: are these stories simply imagination? Or are they echoes of civilizations older than memory, erased but not forgotten? And so, the myths of the first people lead us to another mystery, one not preserved in story alone, but perhaps in stone. Beneath the seas and along forgotten coasts lie ruins that challenge our understanding. Some say they are natural formations. Others claim they are remnants of lost worlds. Next, we descend into the waters. to the legend of Atlantis and the other sunken realms that may hold the keys to forgotten chapters of humanity's past. Beneath the restless surface of the oceans, silence reigns. But silence does not mean emptiness. Across the seafloor, stone steps vanish into darkness, walls dissolve into coral, and patterns etched by hands long gone blur beneath waves. The ocean holds secrets, and some believe it holds the ruins of worlds forgotten. The most famous of these is Atlantis. 2.5 millennia ago, the Greek philosopher Plato wrote of a great island civilization. In his dialogues Timaeus and Critias, he described a land beyond the Pillars of Heracles, what we now call the Strait of Gibraltar. Atlantis, he said, was a mighty power, rich in resources, adorned with concentric rings of land and water, its people skilled in engineering and warfare. Yet, according to Plato, in a single day and night of misfortune, the island sank beneath the sea. Was this allegory or history? To some, Plato's account was a metaphor for hubris, a cautionary tale about societies that grow too powerful. To others, it was a memory perhaps imperfect, perhaps exaggerated of a real place destroyed by catastrophe. The story of Atlantis is not alone. Across the globe, myths echo with tales of lands drowned by rising waters. In India, the ancient city of Dwarka, home of the god Krishna, is said to have been swallowed by the sea. For centuries it was dismissed as legend, until divers off the coast of Gujarat discovered ruins, walls, streets, and stone anchors lying beneath the waves. Carbon dating of artifacts suggests they could be thousands of years old, possibly predating the known Indus Valley civilization. In the Pacific, off the coast of Japan's Yonaguni Island, another enigma lies beneath the waves. There, massive stone formations rise from the seafloor terraces, steps and platforms that some claim are the remains of an ancient city. Divers swim through corridors that look carved, past stairways that seem too regular to be natural. Yet geologists debate fiercely. Is Yonaguni a human creation, or merely a natural formation sculpted by time and tide? Further afield, in the Mediterranean, divers have found submerged structures off the coast of Malta, megalithic temples, now resting below the surface. In the Bahamas, the so-called Bimini Road stretches in a straight line beneath shallow waters, a path of massive stones that some insist are the remnants of walls or piers. Scientists argue they are natural beach rock, fractured and shifted by the sea. But the debate persists, fueled by the allure of possibility. Why do so many of these stories and sites lie beneath the ocean? The answer may be written in ice. At the end of the last ice age, around 12,000 years ago, glaciers covering much of the Earth melted, and sea levels rose by more than 100 meters. Entire coastlines were swallowed, and with them, any settlements that early humans might have built. What today lies far offshore may once have been fertile land, river valleys, and thriving communities. Imagine a village on a coastal plain, its people skilled in fishing, farming, perhaps even building with stone. To them, the ocean is both gift and danger. And then, over generations, the sea begins to creep higher. First, fields vanish. Then, homes. Then, the village itself is taken. Those who survive move inland, carrying stories of a world lost to the waves. Over millennia, the memory hardens into myth. This pattern is not confined to any one culture. Aboriginal Australians tell of landscapes that once lay dry, now beneath the sea, knowledge preserved across more than 7,000 years of oral tradition. The Celtic legends of Cantor Gweled speak of a Welsh kingdom drowned by rising waters. In the North Sea, fishermen still speak of Doggerland, a vast plain that once connected Britain to continental Europe, now a sunken world beneath the waves. When myth and geology align, the question arises: are we looking not at imagination, but at memory? If civilizations existed along those now submerged coasts, their ruins would lie hidden, buried beneath silt, unreachable except by divers and sonar. Modern archaeology, focused largely on land, has barely touched the vast underwater archives of human history. And so, Atlantis becomes more than a legend. Dwarka becomes more than a story. Yonaguni becomes more than a puzzle. Together, they are symbols of possibility. That humanity's story is older and more complex than the surface record suggests. The ocean guards its secrets well. Currents erode stone, coral reclaims walls, sand buries cities. Yet each discovery, an anchor, a wall, a road beneath the waves, reminds us that history is not as solid as we think. Whole chapters may be missing, drowned beyond reach, waiting for us to rediscover them. But if civilizations once thrived and fell, drowned by rising seas, what else might they have left behind? Did they master tools and technologies now lost to us? Did they chart the skies or map the globe long before our recorded ancestors? The next clues are not found beneath the ocean, but in stone and fire, the two materials that shape the destiny of early humanity. In the beginning, there was fire. For our species, no discovery has been more transformative. Fire gave warmth in the cold, safety in the dark, and a way to cook food that unlocked new sources of energy. It hardened wood into spears, turned clay into pottery, and in time, gave birth to metallurgy, the art of shaping stone into steel. Mainstream history celebrates fire as one of the keystones of human progress. The archaeological record traces its use back nearly 1 million years. Charcoal stains in ancient caves, scorched stones arranged in forgotten hearths. By around 10,000 years ago, fire, tools, and agriculture together launched the great experiment we call civilization. But what if this was not the beginning? What if the spark we call invention was actually a rediscovery? Across the world, myths whisper of ancient peoples who wielded fire with mastery far beyond their time. In the Greek tradition, it was Prometheus who stole flame from the gods to give to mankind, a gift both divine and dangerous. The Hindu texts speak of Agni, the sacred fire, carried from age to age, eternal and undying. In Zoroastrian temples, fire burns without ceasing, a symbol of continuity across generations. Perhaps these myths are not about invention, but memory. A memory of fire, not as a newfound tool, but as a legacy and inheritance passed down from those who came before. Consider the odd stories of ancient metallurgy. In South America, evidence of sophisticated alloys has appeared in contexts that seem older than the civilizations usually credited with them. In India, the famous Iron Pillar of Delhi stands after more than 1,600 years, resisting rust in ways modern metallurgists still puzzle over. Egyptian texts mention the metal of the gods, forged in ways that modern science struggles to replicate when considering the technology supposedly available to the ancients. And then there are the outliers, the whispers of tools and forges that should not exist. At sites in Turkey and Mesopotamia, researchers have uncovered slag, the byproduct of smelting, that may predate the Bronze Age. In South Africa, circular stone ruins known as Adam's Calendar are surrounded by reports of ancient mining and possible furnaces, some of which have been controversially dated to tens of thousands of years old. If true, this suggests not the birth of metallurgy, but its rebirth after a long forgetting. Fire itself is a double-edged sword. It builds and it destroys. It is warmth and it is ruin. Entire landscapes have been reshaped by flames, some ignited naturally, others sparked by human hands. When ancient myths speak of worlds ending in fire, we cannot help but wonder, were these only metaphors? Or could they recall real catastrophes, volcanic eruptions, meteoric impacts, or even the destructive misuse of fire by civilizations now erased? Agriculture tells a similar tale. The mainstream story is simple. Around 10,000 years ago, humans learned to plant seeds, domesticate animals, and cultivate crops. From this blossomed cities, writing, mathematics, and empires. But what if agriculture, too, was not an invention, but a rediscovery? In the mythology of the Hopi people, the gods gave corn to humans as a gift from a previous world. In Sumerian texts, farming appears not as an innovation, but as knowledge imparted by the gods' knowledge that humans received, not created. Could this reflect a cultural memory of an earlier cycle of humanity, one that already knew how to till the earth and passed fragments of that wisdom to survivors? The puzzle grows stranger with the odd survival of out-of-place artifacts. Hammers encased in rock, metallic spheres found in ancient strata, and tools that defy easy categorization have fueled speculation for decades. While skeptics dismiss most as misidentifications or natural formations, they remain tantalizing symbols of possibility, reminders that our story may not be as linear as the textbooks claim. If fire, metallurgy, and agriculture were rediscoveries, it forces a deeper question. Who was here before us? Were there cultures that rose, flourished, and then vanished, leaving only embers for us to reignite? The archaeological record is often described as incomplete, but perhaps incomplete is an understatement. Fires destroy evidence. Floods bury it. Time itself grinds civilizations into dust. What little survives may only be the faintest trace of something much greater. To us, fire is progress. But to an ancient world, it may have been both salvation and undoing. Imagine a civilization that learned to harness fire not just for warmth or cooking, but on scales we cannot imagine, burning forests, smelting metals, forging weapons that scarred the land itself. Imagine fire turned not toward life, but toward destruction. If such a civilization once existed, its downfall might explain why myths carry such warnings. Prometheus punished, fire stolen from gods, knowledge bound with consequences. Fire is always paired with responsibility. Without wisdom, it consumes not only forests and cities, but entire civilizations. In the glow of firelight, we are reminded of both our beginnings and our fragility. Each flame carries a story of survival, of innovation, of destruction, of rebirth. And perhaps, in its flickering dance, we glimpse not only our ancestors, but also the shadows of forgotten versions of humanity who once lit the night before us. But fire is not the only inheritance we may have received. If earlier worlds of humanity existed, they may have left behind not only sparks and embers, but also monuments written in stone. Silent structures, larger and older than our history allows, waiting for us to listen. Sometimes the past speaks not through monuments or myths, but through objects small, fragile things that surface in the most unlikely of places. Archaeologists call them anomalies. The public knows them as out-of-place artifacts, ooparts. Each one is like a whisper out of time, a challenge to the tidy story of linear progress. Some can be explained away. Others refuse to vanish so easily. And together, they force us to ask, what if the past is far stranger than we've been taught? Take, for instance, the Antikythera mechanism. Discovered in 1901 in the wreck of a Roman-era ship near a Greek island, it first appeared as little more than corroded bronze fragments. Yet when scientists looked closer, they found interlocking gears designed with precision that would not reappear in Europe until the 14th century, more than 1,000 years later. The mechanism turned out to be a kind of analog computer, capable of predicting eclipses, lunar phases, even the movements of planets. In the mainstream timeline, such complexity had no place in the ancient Mediterranean. And yet, there it was, built by hands that knew far more than they should have. Some historians attribute it to a lost genius, perhaps inspired by Archimedes or another forgotten inventor. But what if the Antikythera mechanism was not a one-off miracle? What if it was a fragment of inherited knowledge, a memory of technology rediscovered from an earlier world? Then there is the Baghdad battery, a clay jar lined with copper, with traces of acid inside. When first studied in the 1930s, researchers realized that with the right electrolyte, it could generate a mild electric current. In today's language, a battery. But it dates back nearly 2,000 years to the Parthian Empire. The orthodox view is that it was used for electroplating metals or as a simple curiosity. But to others, it raises the possibility of an older, lost understanding of electricity, one that may have been far more widespread than we think. Were the ancients experimenting with forces of nature we only rediscovered in the modern era? Beyond these relatively recent oddities lie stranger, deeper mysteries. In coal seams dated to hundreds of millions of years old, miners have reported finding objects that should not exist. Metallic spheres with grooves. Supposed hammerheads fused into ancient rock. Gear-like shapes embedded in seams formed long before humans were believed to walk the earth. Most of these cases are dismissed as misinterpretations or natural formations. But even if only one were authentic, it would rewrite everything we think we know about human or pre-human history. Did earlier versions of us leave behind tools, only to vanish before our chapter began? The list of OOParts is long and haunting. The London hammer, encased in stone allegedly 100 million years old. The Koso artifact, a spark plug-like object found inside a geode. Crystal skulls carved with such precision that modern diamond-tipped drills would struggle to replicate them. And stories often ridiculed, but persistent of nails, jewelry, and figurines pulled from strata too old to make sense. Mainstream scholars argue that contamination, hoaxes, or natural processes explain them. And in many cases, that is true. But the sheer accumulation of anomalies begins to sound like a drumbeat, faint, inconsistent, yet impossible to ignore. What makes OOParts so unsettling is not just the objects themselves, but what they imply. If even one artifact is genuine, then our timeline is fractured. Our progression is not linear, but cyclical. Civilizations may rise, fall, and leave behind only fragments, objects small enough to slip through the cracks of catastrophe, yet durable enough to survive eons. And myths seem to echo the same warning. Cultures around the world speak of tools given by gods, of sacred objects passed down from lost ages. From the Ark of the Covenant to the Japanese mirror of Amaterasu, the theme repeats, fragments of knowledge carried across worlds. Perhaps OOParts are not just mistakes in the record, but surviving relics of humanity's earlier versions. To skeptics, these artifacts are nothing more than curiosities, their mystery exaggerated by human imagination. But perhaps imagination itself is the key. Our ancestors may have looked at these same objects with wonder, recognizing them as remnants of a world older than their own. In the end, OOParts are not definitive proof. They are questions made solid questions we can hold in our hands. Were these the experiments of forgotten inventors, or the leftovers of forgotten civilizations? Were they accidents of geology, or intentional gifts across time? One thing is certain. Every time we dismiss them, they resurface. Every time the past seems settled, an object appears where it should not be. And together, they whisper the same haunting suggestion. Maybe we are not the first version of humanity. Maybe we are only the latest. And if objects can survive across ages, what of monuments? What of vast stone structures, too large to move, too precise to dismiss? If tools and trinkets raise questions, then megaliths, the giants of stone, shout them. In the summer of 1934, Emma Hahn and her husband Max were walking along a rocky creek bed near London, Texas, when they noticed an unusual piece of stone. Embedded in the weathered limestone was what appeared to be the handle of a tool, its wooden shaft partially exposed where the rock had split. They brought their find home, and over the following decades, as the limestone gradually eroded away, more of the object became visible. What emerged challenged everything they thought they knew about the age of human technology. The object appeared to be an iron hammer with a wooden handle, unremarkable except for its geological context. The limestone in which it was found belonged to the Cretaceous period, formed during the age of dinosaurs more than 100 million years ago. If the geological dating was accurate, the hammer had somehow become incorporated into sedimentary rock long before humans or even mammals existed on Earth. The Han family kept the hammer as a curiosity for years before it came to the attention of researchers. When subjected to analysis, the artifact proved even more puzzling. The iron head showed no signs of rust despite its supposed great age. The metal composition was unusually pure, containing trace elements in ratios that differed from modern steel. Most mysteriously, the wooden handle appeared to have been partially transformed into coal, suggesting exposure to the kind of pressure and chemical conditions that occur only over geological timescales. Skeptics quickly proposed explanations for the anomaly. Perhaps the hammer was a relatively recent object that had become encased in limestone through rapid mineral deposition from groundwater. Such processes could theoretically create the appearance of great age, while actually requiring only decades or centuries. The limestone formations in central Texas are known for their rapid fossilization properties, and similar encasements of modern objects have been documented. Yet proponents of the hammer's authenticity point to details that resist easy dismissal. The degree of coalification in the wooden handle suggests exposure to conditions that typically require enormous time periods. The purity of the iron and its resistance to corrosion seem unusual for a modern object. Most significantly, the limestone matrix surrounding the hammer shows no evidence of the fracturing and redeposition that would be expected if the object had been inserted into existing rock formations. The London hammer, as it came to be known, represents just one example of supposedly ancient manufactured objects that surface periodically around the world. Similar claims emerge regularly from mining operations, construction projects, and amateur fossil hunting. Each case presents the same basic challenge: how to reconcile objects that appear to show human manufacture with geological contexts that predate human existence by millions or hundreds of millions of years. In Illinois, workers reportedly found an ornate metallic bell inside a lump of coal dated to the Carboniferous period, 300 million years ago. Pennsylvania miners allegedly discovered a metallic object resembling a modern drill bit embedded in coal of similar age. Russian researchers have claimed to find tiny, metallic spirals in rock formations that predate complex life on Earth by billions of years. The pattern of these discoveries follows predictable lines. They typically emerge from contexts mines, quarries, construction sites where rapid extraction and processing made careful documentation difficult. They often involve workers who lack formal training in archaeology or geology. The objects themselves usually disappear into private collections before proper scientific analysis can be conducted. Skeptical explanations can almost always be constructed, even if they cannot always be definitively proven. Yet the persistence of such reports raises questions that extend beyond individual cases. Why does this particular type of anomaly appear with such regularity? What does it tell us about the challenges of interpreting archaeological and geological evidence? And what are the implications if even a small percentage of these reports represent genuine mysteries? The theoretical possibility that such objects could be authentic forces, consideration of scenarios that challenge fundamental assumptions about Earth's history. If manufactured objects genuinely existed in geological contexts millions of years old, they would require either the existence of advanced civilizations far earlier than currently believed possible, or some kind of temporal displacement that moved objects backward through time, a possibility that violates our understanding of physical law. More modest explanations suggest that some of these objects might represent natural formations that coincidentally resemble manufactured items. Geological processes can create remarkably regular shapes, particularly in mineralogically active environments. The human tendency to perceive familiar patterns in random formations could account for at least some reports of ancient machinery or tools. The psychological dimensions of these discoveries deserve consideration as well. In an age when technological advancement defines human achievement, finding evidence of ancient technology satisfies both curiosity about the past and validation of the importance of technical capabilities. The desire to discover proof of lost civilizations or forgotten knowledge may unconsciously influence how anomalous objects are interpreted and reported. Scientific methodology provides tools for evaluating such claims, but applying these tools requires access to the objects themselves, detailed documentation of their discovery contexts, and the resources to conduct comprehensive analyses. In most cases involving allegedly ancient manufactured objects, one or more of these requirements cannot be met, leaving the mysteries unresolved. The London hammer remains in private hands, displayed in a small creation science museum where visitors can examine it for themselves. Its true age and origin may never be definitively established, leaving it as either a curious example of rapid fossilization or a profound mystery that challenges our understanding of human history. In the end, perhaps the hammer's greatest significance lies not in what it proves or disproves, but in the questions it forces us to confront about the nature of evidence, the reliability of our dating methods, and the possibility that the past might hold surprises that our current theories cannot accommodate. Whether genuine anomaly or misinterpreted curiosity objects, like the London hammer, serve as reminders that the geological record may be far more complex than we assume, and that the story of human technology might extend much further back in time than we have yet dared to imagine. The asteroid streaks through the thin atmosphere of a younger Earth, its surface still glowing from its journey through space. In the shallow seas that cover much of what will one day become Mexico's Yucatan Peninsula, marine reptiles pursue schools of fish through coral reefs that have thrived for millions of years. On distant continents, dinosaurs feed in vast forests beneath a warmer sun. None of these creatures can imagine that their entire world will be transformed within hours of the impact that is about to occur. The Cretaceous-Paleogene extinction event, which ended the age of dinosaurs 66 million years ago, represents just one chapter in a story that has repeated throughout Earth's history. 5 times in the geological record, mass extinction events have swept away the dominant life forms of their eras, clearing the stage for entirely new evolutionary experiments. Each catastrophe eliminated not just individual species, but entire ecosystems, forcing life to rebuild itself from whatever survivors managed to endure the global transformation. The pattern revealed by paleontology is both humbling and thought-provoking. For over 160 million years, dinosaurs dominated terrestrial ecosystems, developing sophisticated social behaviors, complex body plans, and even early forms of intelligence. Some species showed evidence of advanced problem-solving abilities, elaborate courtship rituals, and parental care that rivaled modern mammals. Yet this vast dynasty vanished so completely that mammals, previously relegated to small ecological niches, inherited an empty world and radiated into forms that would eventually produce consciousness as we understand it. But the dinosaurs were neither the first nor the last to experience such comprehensive replacement. Before them, the Permian extinction, the most severe crisis in Earth as history, eliminated over 90% of marine species and 70% of terrestrial vertebrates. This event, occurring 252 million years ago, came closer than any other to ending complex life entirely. The recovery took millions of years and resulted in ecosystems fundamentally different from those that had preceded the catastrophe. Earlier still, the late Ordovician extinction ended the dominance of trilobites and other invertebrates that had ruled the seas for hundreds of millions of years. The late Devonian event transformed marine ecosystems and may have delayed the evolution of complex vertebrates by tens of millions of years. Each mass extinction represents not just the end of particular species, but the conclusion of entire chapters in the story of life on Earth. These patterns raise profound questions about the relationship between intelligence and survival. If dinosaurs, despite their evolutionary success and longevity, could be eliminated by environmental catastrophe. What does this suggest about the long-term prospects for intelligence itself? If creatures that dominated their world for geological ages could vanish so completely that only their fossils remain, might not the same fate await any intelligent species, regardless of their technological achievements? The question becomes more pressing when we consider the possibility that intelligence might have evolved multiple times during Earth's long history. Dinosaurs showed increasing brain complexity throughout their reign. Some species developed sophisticated social structures, elaborate communication systems, and problem-solving abilities that approached those of modern intelligent animals. A few researchers have even suggested that given more time, certain dinosaur lineages might have evolved human-level intelligence. The marine reptiles of the Mesozoic era demonstrated remarkable adaptations to their environment. Dolphins and whales today show that marine mammals can develop complex social structures, sophisticated communication, and problem-solving abilities that in some cases exceed those of terrestrial animals. If similar intelligence had evolved among marine reptiles during the hundreds of millions of years they dominated the oceans, would any trace of their achievements remain after mass extinction and the geological transformation of ocean basins? Even more intriguing are the possibilities presented by earlier eras. The Carboniferous period, with its vast forests and stable climate, lasted for 60 million years, long enough for complex intelligence to evolve multiple times over. Some amphibians and early reptiles of this era reached considerable size and showed evidence of complex social behaviors. If any lineage had developed tool use and technology during this immense span of time, would evidence of their civilization survive the geological processes that transformed their world? The challenge of recognizing ancient intelligence in the geological record is immense. Human civilization, despite its apparent permanence, would leave surprisingly little lasting evidence if subjected to mass extinction and millions of years of geological processing. Our cities would erode, our metals would corrode, and our most durable artifacts would be buried beneath layers of sediment. Future paleontologists might find only the briefest geological signature of our existence, perhaps a thin layer of unusual isotopes marking the Anthropocene epoch. If human-level intelligence could leave such a subtle geological footprint, how much less likely would we be to recognize the traces of intelligence that evolved and disappeared hundreds of millions of years ago? The very processes that preserve fossils favor hard structures like bones and shells over the manufactured materials that intelligent species might create. Technology based on organic materials, wood, fiber, even early metals would vanish almost completely from the geological record given sufficient time. Some researchers have begun to consider what they call the Silurian hypothesis, named after the fictional reptilian species from Doctor Who. This thought experiment asks whether we would be able to detect the existence of an industrial civilization that existed millions of years ago. The answer, surprisingly, is that such detection would be extremely difficult using current paleontological methods. Only very specific types of evidence might survive. Unusual isotope ratios in sedimentary layers, perhaps, or the kind of rapid climate change that might result from industrial activity. The mass extinctions themselves present another layer of mystery. While some have clear causes, the asteroid impact that ended the dinosaurs, the massive volcanism associated with the Permian extinction, others remain poorly understood. Could some of these catastrophes have been triggered or accelerated by the activities of intelligent species? Could the development of intelligence itself sometimes lead to the kind of environmental changes that cause mass extinction? These questions become more than academic when we consider our own situation. Human activity is already causing what many scientists consider to be the beginning of a sixth mass extinction. Species are disappearing at rates that exceed background extinction levels by orders of magnitude. Climate change, habitat destruction, and pollution are transforming global ecosystems in ways that parallel some of the great extinction events of the past. If we are indeed participants in a mass extinction event, If our own intelligence and technology are contributing to global environmental transformation, then we may be following a pattern that has repeated throughout Earth's history. Perhaps the development of intelligence, by allowing species to exploit their environment more effectively, inevitably leads to the kind of global changes that trigger mass extinction. Perhaps consciousness itself, despite its apparent advantages, represents an evolutionary dead end when viewed over geological timescales. Or perhaps some intelligent species manage to navigate these challenges and achieve long-term stability. Perhaps somewhere in Earth's deep past, intelligent beings faced similar crises and found ways to survive, their civilizations continuing through changes that appear catastrophic from our perspective. If so, their stories remain hidden in rocks and fossils that we have not yet learned to read properly. The ice sheets stretch endlessly toward every horizon, their crystalline surfaces reflecting a sun that provides light but little warmth. Beneath these frozen plains, hundreds of feet of compacted snow hold the water that once filled the world's oceans, lowering sea levels by 400 feet and exposing vast continental shelves that today lie hidden beneath the waves. This is Earth during the last glacial maximum 20,000 years ago, when ice covered a third of the planet's land surface and created a world so different from our own that it might as well belong to another planet. Yet even in this frozen world, life persisted. Humans not only survived the Ice Age, but began to display the first signs of the cultural sophistication that would eventually flower into civilization. The cave paintings of Lascaux and Altamira, dating to the height of the glacial period, demonstrate artistic abilities that rival anything produced by later cultures. The ivory carvings and sophisticated tools found at sites across Europe and Asia reveal technical capabilities that challenge our assumptions about primitive Ice Age peoples. But the most profound transformations occurred when the ice began to retreat. Starting around 18,000 years ago, the great ice sheets that had locked away so much of the world's water began their inexorable melting. The process was not gradual. Geological evidence reveals that Ice Age sea level rise was punctuated by periods of catastrophically rapid change, during which ocean levels could rise several feet per decade. Entire landscapes vanished beneath the waves within single human lifetimes. The implications for human civilization were profound. During the Ice Age, the most favorable areas for human settlement were precisely those coastal plains and river valleys that would be the first to disappear beneath rising seas. These fertile lowlands, watered by rivers swollen with glacial melt and protected from the harsh continental climate, would have been ideal locations for the development of complex societies. If any Ice Age cultures had achieved true civilization permanent settlements, agriculture, monumental architecture, the evidence now lies beneath hundreds of feet of ocean water. Recent archaeological discoveries have begun to reveal the sophisticated nature of Ice Age human societies. Göbekli Tepe in Turkey, with its massive stone pillars and complex astronomical alignments, was built by people who were supposedly simple hunter-gatherers just emerging from the Ice Age. The site's construction required organizational capabilities, specialized knowledge, and labor coordination that challenge fundamental assumptions about the development of human social complexity. Similar sites are being discovered across the globe, many dating to the immediate aftermath of the Ice Age melting. These monuments suggest that the transition from Ice Age to modern world was accompanied by a florescence of human achievement that has no parallel in later history. Within a few thousand years, humans went from leaving artistic masterpieces in caves to building sophisticated stone monuments, developing agriculture, and establishing permanent settlements. The rapidity of this transformation raises uncomfortable questions. How did scattered bands of hunter-gatherers suddenly acquire the knowledge needed for complex architecture and agriculture? Why do some of the earliest known monuments demonstrate construction techniques that later cultures struggled to match? And why do so many ancient traditions speak of knowledge being recovered rather than invented after a period of global catastrophe? The Younger Dryas period, occurring roughly 12,800 to 11,700 years ago, adds another layer of mystery to this story. Just as the world was warming and ice sheets were retreating, global temperatures suddenly plummeted back to near glacial conditions for over 1,000 years. This climatic reversal, which occurred with startling rapidity, would have been catastrophic for any human societies that had adapted to the warming conditions of the preceding millennia. Recent research has suggested that the Younger Dryas cooling may have been triggered by a cosmic impact, fragments of a comet or asteroid striking the North American ice sheet. The evidence includes microscopic diamonds and other impact markers found in sediment layers corresponding to the beginning of the cooling period. Elevated levels of platinum and other elements typically associated with extraterrestrial impacts, and a layer of carbon-rich material suggesting widespread fires across the continent. If this cosmic impact hypothesis is correct, it implies that human societies at the end of the Ice Age faced not just the gradual challenge of rising sea levels, but sudden, catastrophic destruction followed by a return to near-glacial conditions. Any civilizations that had developed during the initial warming period would have been subjected to multiple catastrophes within a relatively short span of time. The geological record preserves evidence of these dramatic environmental changes, but it is largely silent about their human impact. We know that some populations survived. They were the ancestors of the agricultural societies that emerged after the Younger Dryas ended. But we have almost no information about what kinds of societies existed during the transition period, how they adapted to rapidly changing conditions, or what knowledge they might have possessed and lost. The Persian Gulf offers a tantalizing glimpse of what might be hidden beneath post-glacial flooding. During the Ice Age, this body of water was a river valley supporting human populations for thousands of years. As sea levels rose, these societies would have been forced to migrate inland, potentially carrying with them the cultural achievements of their drowned homeland. Some researchers have suggested that the sophisticated early civilizations of Mesopotamia might represent the continuation of cultural traditions that originated in the now submerged Persian Gulf basin. Similar scenarios could have played out around the world. The North Sea was dry land during the Ice Age, supporting human populations and potentially complex societies. The coastal plains of every continent contained areas that would have been prime locations for early civilization, but now lie beneath the waves. The archaeological investigation of these drowned landscapes has barely begun, but each expedition reveals new evidence of human presence in areas that have been underwater for thousands of years. The mythology of peoples around the world preserves memories that might relate to these dramatic environmental changes. Flood narratives are nearly universal in human cultures, often describing not just local inundations, but global catastrophes that transform the entire world. These stories frequently include details that match what we now know about post-glacial flooding: the sudden appearance of vast amounts of water, the drowning of entire landscapes, and the survival of only small populations who must rebuild civilization from scattered remnants. Some of these traditions specifically describe the loss of advanced knowledge and technology during global catastrophes. Hindu texts speak of previous ages when humans possessed capabilities that were later lost. Native American traditions describe cycles of destruction and renewal, during which the achievements of previous worlds are swept away. Celtic mythology preserves accounts of advanced societies that disappeared beneath the waves, taking their knowledge with them. As climate scientists work to understand the mechanisms of rapid climate change, as marine archaeologists explore drowned landscapes, and as geneticists trace the population movements that followed the Ice Age melting, a more complex picture of this crucial period in human history begins to emerge. The transition from Ice Age to modern world may have been far more traumatic and transformative than previously realized, involving not just environmental change, but the rise and fall of human societies, whose achievements we are only beginning to glimpse. The Ice Age world and its aftermath may hold keys to understanding not just how human civilization began, but how it has risen and fallen multiple times in response to environmental catastrophe. Beneath the waves and buried in the geological record may lie evidence of ghost civilizations, whose existence challenges our most basic assumptions about the linear progression of human development. The Turkish hillside rises gently from the surrounding plains, its grassy slopes giving no hint of the mystery buried beneath 20 feet of accumulated soil and debris. For thousands of years, this modest elevation near the town of Kanlıyarfa concealed what may be humanity's most revolutionary archaeological discovery. When excavations began at Göbekli Tepe in the 1990s, archaeologists expected to find another routine Neolithic settlement. Instead, they uncovered evidence that forced a complete reconsideration of how human civilization began. The massive stone pillars that emerged from the ancient soil stand up to 18 feet tall and weigh as much as 16 tons each. Carved from limestone quarried nearby, they are arranged in precise circles that demonstrate sophisticated understanding of engineering and astronomy. But what makes Göbekli Tepe truly revolutionary is its age. Radiocarbon dating places the site's construction at approximately 11,600 years ago, making it older than Stonehenge by 6,000 years and older than the pyramids of Egypt by 7,000 years. According to mainstream archaeological theory, the people who built Göbekli Tepe should not have possessed the social organization, technical knowledge, or surplus resources necessary for such an undertaking. The site predates the supposed invention of agriculture by nearly 1,000 years, placing its construction firmly in the period when humans lived as small bands of hunter-gatherers. Yet the monument's complexity suggests a level of social cooperation and specialized knowledge that contradicts everything archaeologists thought they knew about human development during this period. The pillars themselves are masterworks of stone carving, decorated with intricate reliefs of animals, abstract symbols, and human figures. The artistic sophistication rivals that of much later civilizations, while the symbolic complexity suggests a rich mythological or religious system that guided the site's construction. Some of the symbols appear to be early forms of writing or notation, potentially pushing back the invention of symbolic communication by thousands of years. Even more puzzling is the scale of the undertaking. Göbekli Tepe consists of multiple circular enclosures, each requiring the quarrying, transport, and precise placement of dozens of massive stone pillars. The logistics alone would have required hundreds of workers laboring for years or decades. Yet there is no evidence of permanent settlement at the site. No houses, no storage facilities, no signs of daily life. The builders apparently came from elsewhere, completed their monumental work, and departed. The site's astronomical alignments add another layer of complexity. The stone circles appear to have been oriented toward specific stars and constellations, suggesting sophisticated knowledge of celestial mechanics. Some researchers believe the site may have served as an ancient observatory, used to track seasonal changes and predict celestial events. This interpretation implies mathematical and astronomical knowledge that shouldn't have existed among supposedly primitive hunter-gatherers. But Göbekli Tepe is not unique. As archaeologists have begun looking more carefully at sites from the immediate post-Ice Age period, similar discoveries have emerged around the world. In Turkey alone, dozens of related sites have been identified, some potentially even older than Göbekli Tepe. The region appears to have been the center of a sophisticated culture that flourished during the transition from Ice Age to modern climate conditions. Karahan Tepe, discovered just 30 miles from Göbekli Tepe, contains similar massive stone pillars and complex symbolic carvings. Preliminary investigations suggest it may be even older than its famous neighbor. Other sites in the region, Nevali Kori, Kayaun, and Jirf El Amr, show evidence of advanced stoneworking techniques, sophisticated architecture, and complex symbolic systems that predate the supposed beginnings of civilization by thousands of years. The pattern extends beyond Turkey. In Armenia, the Karahan stone circle, also known as Zaratskara, consists of over 200 standing stones arranged in patterns that suggest astronomical observations. While its dating remains controversial, some researchers propose it could be as old as Göbekli Tepe. The site's name translates to speaking stones, reflecting local traditions that attribute special properties to the ancient monument. In the Caucasus Mountains, megalithic structures called dolmens dot the landscape. These stone chambers, built from massive blocks fitted together with precision, were traditionally attributed to Bronze Age cultures. However, recent research suggests some may be far older, potentially dating to the same period as the Turkish monuments. Their construction techniques and astronomical orientations show remarkable similarities to other early megalithic sites around the world. The implications of these discoveries extend far beyond archaeology. If hunter-gatherer societies could organize the construction of massive stone monuments, maintain sophisticated astronomical knowledge, and develop complex symbolic systems, then our understanding of human social evolution requires fundamental revision. The site suggests that the capacity for complex civilization existed thousands of years before it supposedly emerged in Mesopotamia and Egypt. Some researchers have proposed that these early monuments represent a lost chapter in human development, flowering of sophisticated culture that occurred during the immediate aftermath of the Ice Age, only to be disrupted by the climatic catastrophe of the Younger Dryas period. According to this theory, the builders of Göbekli Tepe and similar sites possessed advanced knowledge that was partially lost during the thousand-year return to near-glacial conditions, forcing later societies to rebuild civilization from fragmentary remains. Others suggest that these sites represent evidence of knowledge transmission from even earlier periods. The sophistication of the monuments, the precision of their astronomical alignments, and the complexity of their symbolic systems might reflect the preservation of information from previous cycles of human development. The builders before builders might themselves have been working with inherited knowledge from still earlier civilizations. The deliberate burial of Göbekli Tepe adds another mystery to the site's story. Around 8,000 years ago, someone made the decision to cover the entire complex with thousands of tons of soil and debris. This was not natural accumulation, but intentional concealment, requiring almost as much labor as the original construction. Why would a society choose to hide such an important site? What prompted them to erase their own achievement from the landscape? The answer may lie in the changing world that emerged after the Ice Age. As agriculture developed and human societies became more complex, the worldview represented by Göbekli Tepe may have become obsolete or even threatening to new social orders. The site's burial might represent not just concealment, but a conscious break with earlier traditions, a decision to leave the past behind and embrace new ways of organizing human society. As excavations continue at Göbekli Tepe and related sites, as new dating techniques refine our understanding of their age, and as similar monuments are discovered around the world, the story of civilization's beginnings grows more complex. The builders before builders are forcing us to reconsider not just when human societies became capable of monumental architecture, but why such knowledge emerged so early in human development, and what happened to the cultures that possessed it. These ancient monuments stand as silent witnesses to capabilities that humans possessed long before they were supposed to have developed them, raising profound questions about the nature of human development and the possibility that our current understanding of the past represents only the latest chapter in a much longer and more complex story. In laboratories around the world, scientists peer into the molecular machinery of human heredity, reading the chemical letters that spell out our species' deepest secrets. The human genome, fully sequenced at the dawn of the 21st century, was expected to provide clear answers about our origins, our migrations, and our relationships to other species. Instead, it has revealed a story far more complex and mysterious than anyone anticipated, a narrative written in DNA that speaks of ghost populations, unexplained genetic variations, and ancestral lineages that vanish into shadows of deep time. The mainstream story of human evolution, as told through genetics, describes a relatively straightforward journey. Modern humans evolved in Africa, where they developed the characteristic genetic markers that define our species. Around 70,000 years ago, small populations began migrating out of Africa, eventually spreading across the globe and adapting to new environments. Along the way, they encountered and sometimes interbred with archaic human species Neanderthals in Europe and Asia, Denisovans in Asia and Oceania. This narrative seemed complete until more sophisticated genetic analysis began revealing anomalies that didn't fit the simple model. The first puzzle emerged from studies of Neanderthal DNA extracted from ancient bones. Rather than showing a clear separation between modern humans and their archaic cousins, the genetic evidence revealed extensive interbreeding. Most people of European and Asian descent carry significant amounts of Neanderthal DNA, while people of Melanesian ancestry show evidence of both Neanderthal and Denisovan heritage. But the mysteries deepened as researchers looked more closely at the patterns of genetic variation within modern human populations. African populations, supposedly the direct descendants of our species' ancestral homeland, showed unexpected diversity that suggested complex population structures and multiple migration events. Some genetic lineages appeared to have separated from the main human family tree hundreds of thousands of years ago, far earlier than current models of human evolution would predict. The discovery of ghost populations has added another layer of complexity to the human story. These are groups of ancient humans whose existence is revealed only through their genetic contributions to modern populations. They left no fossil remains that we have identified, no archaeological sites that we can definitively attribute to them. Yet their DNA persists in modern humans as evidence of encounters that occurred tens of thousands of years ago. One such ghost population appears to have contributed DNA to modern Africans, suggesting that our species' evolutionary history in its ancestral homeland was far more complex than previously believed. Another phantom lineage shows up in the genetics of Southeast Asian and Oceanian populations, representing an unknown hominin species that modern humans encountered and interbred with during their expansion across the region. Even more intriguing are genetic patterns that suggest the possibility of much older admixture events. Some researchers have identified DNA sequences in modern humans that appear to derive from populations that separated from our ancestral lineage, not thousands, but hundreds of thousands of years ago. If these interpretations are correct, they imply that anatomically modern humans were encountering and interbreeding with other human-like species far earlier than current models suggest. The analysis of ancient DNA has revealed additional puzzles. Genetic material extracted from human remains dating to different periods shows unexpected patterns of relationship and migration. Some ancient populations appear to be genetically distinct from any modern groups, suggesting that entire lineages of humans have disappeared from the gene pool. Others show genetic characteristics that seem too modern for their supposed age, or too archaic for their known date. Mitochondrial DNA, inherited only through the maternal line, tells its own complex story. The patterns of variation in mitochondrial genomes suggest multiple waves of expansion out of Africa, some much earlier than the accepted timeline for modern human migration. The most recent common ancestor of all mitochondrial lineages, mitochondrial Eve, lived approximately 200,000 years ago. But the distribution of her descendants implies a more complex pattern of population expansion and contraction than simple migration models can explain. Y chromosome analysis, tracing paternal lineages, reveals similar complexities. Some genetic markers suggest that certain populations experienced severe bottlenecks periods when their numbers dropped to very small levels, followed by rapid expansion. These demographic events don't always correspond to known environmental or archaeological changes, raising questions about what forces shaped ancient human populations. The genetic evidence for human cognitive and cultural evolution presents its own puzzles. Genes associated with brain development, language capability, and social behavior show patterns of variation that don't always match archaeological evidence for when these capabilities emerged. Some variants associated with advanced cognitive abilities appear to be much older than expected, while others seem to have spread through human populations more recently than archaeological evidence would suggest. Particularly intriguing are genetic variants that appear to have been subject to strong positive selection, meaning they provided significant survival or reproductive advantages, but whose function remains unknown. These sequences suggest that human evolution involved the development of capabilities that provided major advantages but left no clear archaeological signature. Could some of these mystery genes relate to cognitive or cultural abilities that we do and fully recognize in the archaeological record? The genetics of human adaptation to different environments also reveals unexpected patterns. Some populations show genetic adaptations to conditions that no longer exist in their current habitats, suggesting that they evolved in different environments before migrating to their present locations. Others lack genetic adaptations to conditions that have existed in their regions for thousands of years, implying more recent arrival than archaeological evidence suggests. Population genetics models have begun incorporating these complexities, proposing scenarios involving multiple migration waves, population replacements, and complex patterns of admixture between different human lineages. These models often require assuming the existence of human populations for which we have no direct archaeological evidence groups that lived in regions now underwater, or whose remains have not been preserved or discovered. Some researchers have begun to suggest that the genetic evidence points toward a more complex model of human evolution than the simple out of Africa narrative. They propose that modern human characteristics may have evolved in multiple locations through gene flow between partially separated populations, rather than in a single African homeland. This multi-regional model had been largely abandoned based on earlier genetic studies, but new evidence is forcing its reconsideration. The possibility that some genetic lineages represent contact with unknown hominin species raises even more profound questions. If modern humans encountered and interbred with species we haven't identified in the fossil record, what were these beings? How sophisticated were they? Could some of them have developed cultural or technological capabilities that influenced early human development? As genetic technology continues advancing, as ancient DNA extraction techniques improve, and as researchers analyze genomes from more diverse populations and time periods, the human story grows increasingly complex. Each new dataset reveals additional layers of population movement, admixture, and evolutionary change that challenge simple narratives about human origins and development. The genetic puzzle of humanity suggests that our species' history involves far more complexity than we have yet recognized. Hidden in our DNA be evidence of encounters with unknown human species, population movements across landscapes now underwater, and evolutionary processes that shaped capabilities we don't fully understand. The ghosts in our genes whisper of a past far stranger and more complex than any single narrative can encompass. In the pre-dawn darkness of the Malian countryside, a Dogon elder points toward the constellation of Orion, his weathered finger tracing patterns of stars that have guided his people's ceremonies for countless generations. But his knowledge extends far beyond what the naked eye can perceive. He speaks of Po-Tolo, the companion star of Sirius, describing its 50-year orbital period, its incredible density, and its crucial role in the cosmic order. What makes this knowledge remarkable is that Po-Tolo, known to astronomers as Sirius B, is a white dwarf star invisible to the naked eye, not confirmed by Western science until 1862 and not photographed until 1970. The Dogon astronomical knowledge represents just one example of a pattern that emerges when researchers examine the scientific understanding preserved in ancient cultures around the world. Time and again, traditional peoples demonstrate precise knowledge of celestial phenomena that shouldn't have been observable without sophisticated instruments, mathematical frameworks that rival modern techniques, and cosmological models that anticipate discoveries made only recently by professional astronomers. The ancient Maya developed calendrical systems of stunning precision, tracking not just the obvious cycles of sun and moon, but the complex movements of Venus, Mars, and other planets. Their calculations of the length of the solar year were more accurate than the Julian calendar used in Europe until the 16th century. They predicted eclipses hundreds of years in advance and maintained astronomical records that spanned millennia. Most remarkably, they were aware of the precession of the equinoxes, the slow wobble of Earth's axis that takes 25,920 years to complete, phenomenon so subtle that it requires centuries of careful observation to detect. This same awareness of precessional cycles appears in cultures across the globe, despite the mathematical sophistication required to calculate such enormous time periods. The ancient Egyptians encoded precessional knowledge in their mythology, describing the slow movement of the ages as different gods ruled the sky. Hindu and Buddhist cosmologies describe vast cosmic cycles that match precessional periods with remarkable accuracy. Norse mythology speaks of the slow grinding of the world mill, a metaphor that some researchers interpret as describing precessional motion. The precision of ancient astronomical knowledge often exceeds what seems necessary for agricultural or navigational purposes. The stone circles of Britain and Ireland demonstrate awareness of complex, celestial cycles that extend far beyond the basic seasonal markers needed for farming. Newgrange in Ireland, built over 5,000 years ago, is aligned to capture the winter solstice sunrise in its inner chamber, but recent analysis has revealed that the monument also tracks other astronomical phenomena over much longer periods. Polynesian navigators crossed thousands of miles of open ocean using only their knowledge of stars, currents, and weather patterns. Their navigational techniques, passed down through oral tradition for generations, demonstrate understanding of celestial mechanics that rivals modern navigation. They could determine their position within a few miles after weeks at sea, guided by star patterns, ocean swells, and subtle environmental cues that Western science is only beginning to appreciate. The ancient Babylonians developed mathematical astronomy that formed the foundation for later Greek and Islamic scientific traditions. Their ephemeris tables predicted planetary positions with remarkable accuracy, while their mathematical techniques anticipated many concepts not formally developed in Western mathematics until the medieval period. They understood that apparent retrograde motion of planets resulted from Earth's own movement, an insight that wouldn't be accepted in European astronomy until the Copernican revolution. Even more puzzling is evidence that some ancient cultures possessed knowledge of astronomical phenomena that weren't rediscovered by modern science until the space age. Aboriginal Australian traditions describe the varying brightness of Betelgeuse, the red giant star in Orion, with details that match modern observations of this variable star. Some African cultures preserve knowledge of Saturn's rings and Jupiter's moons, celestial features invisible to the naked eye. The question of how ancient peoples acquired such sophisticated astronomical knowledge has long puzzled researchers. The conventional explanation suggests that these cultures devoted enormous resources to systematic sky observation over many generations, gradually accumulating the data needed for precise calculations. Patient observation and record-keeping, combined with mathematical insight, could theoretically account for even the most sophisticated ancient astronomical achievements. Yet this explanation raises its own questions. Why would pre-technological societies invest such enormous effort in astronomical observation that went far beyond their practical needs? How did they maintain the institutional continuity required for observations spanning millennia? And why does similar knowledge appear in cultures separated by vast distances and long periods of time? some researchers have begun to consider alternative explanations. Perhaps the astronomical knowledge preserved in ancient cultures represents inheritance from earlier civilizations that possessed more advanced observational capabilities. The precision and sophistication of this knowledge might reflect not gradual accumulation by primitive peoples, but the preservation of information originally developed by cultures with greater technological resources. The possibility gains credibility when we consider how easily astronomical knowledge can be lost. The Library of Alexandria, which housed much of the ancient world's scientific learning, was gradually destroyed over several centuries, taking with it irreplaceable astronomical texts and observational records. The Maya astronomical codices were systematically burned by Spanish colonizers, eliminating detailed records of New World astronomical achievements. Similar losses have occurred throughout history, erasing evidence of scientific capabilities that might have taken centuries to develop. If advanced astronomical knowledge could be lost so easily in historical times, how much more might have vanished during the upheavals of prehistory? The dramatic climate changes at the end of the Ice Age, the catastrophic flooding that submerged vast coastal areas, and the social disruptions that accompanied humanity's transition to agriculture might have destroyed entire traditions of astronomical observation and mathematical calculation. The mythological frameworks that preserve ancient astronomical knowledge often describe this information as being taught to humans by divine beings or culture heroes who possessed superior wisdom. While modern interpretation typically treats these stories as metaphorical, they might preserve memories of actual knowledge transfer from more advanced cultures to less sophisticated ones. The gods who taught astronomy might represent the survivors of earlier civilizations, passing on their scientific heritage to emerging cultures. Some ancient texts explicitly describe astronomical knowledge as having been recovered rather than originally discovered. The Hindu Surya Siddhanta claims to preserve astronomical wisdom from previous cosmic ages. Egyptian texts reference the recovery of knowledge from the time of the gods. Mesopotamian traditions describe the transmission of scientific learning from before the flood. These accounts might represent not mythology, but historical memory of knowledge preservation and transmission across civilizational gaps. The astronomical capabilities demonstrated in ancient monuments and texts suggest that our ancestors possessed scientific resources and institutional capabilities far beyond what conventional archaeology attributes to their cultures. They maintained observational programs spanning millennia, developed mathematical techniques of remarkable sophistication, and created monuments that demonstrate understanding of celestial mechanics that matches or exceeds modern knowledge. As archaeoastronomers continue studying ancient sites, as anthropologists document traditional astronomical knowledge before it disappears, and as historians of science trace the transmission of mathematical concepts across cultures and centuries, the picture of ancient scientific achievement grows more impressive rather than less. The lost knowledge of the stars may represent not primitive superstition, but sophisticated science, preserved against all odds from civilizations whose other achievements have vanished beneath the waves of time. High in the Bolivian Altiplano, where the thin air makes every breath a conscious effort, the ruins of Pumapunku rise from the ancient landscape like fragments of an impossible dream. The massive stone blocks, some weighing over 100 tons, lie scattered across the site as if a giant's construction project had been suddenly abandoned. Yet these are not roughly hewn boulders, but precisely engineered components, cut with tolerances that would challenge modern manufacturing capabilities, and fitted together with joints so perfect that a knife blade cannot slip between them. The mystery deepens with each technological analysis. The stones are andesite and red sandstone, materials so hard that they can only be shaped with diamond-tipped tools or techniques that exceed conventional stone-working capabilities. Yet the surfaces show evidence of machine-precise cutting, with perfectly straight edges, exact right angles, and complex interlocking joints that suggest advanced understanding of structural engineering. Some blocks contain precisely drilled holes that appear to have been made with high-speed rotary tools, while others show evidence of cutting techniques that leave surfaces smoother than what medieval stonemasons could achieve. The precision extends beyond individual blocks to the overall design. The remaining foundations reveal a complex architectural plan that incorporated sophisticated drainage systems, earthquake-resistant construction techniques, and modular design principles that allowed massive structures to be assembled from prefabricated components. The mathematical relationships embedded in the site S proportions suggest advanced understanding of geometry and engineering that shouldn't have existed in pre-Columbian South America. Dating the site presents its own challenges. Conventional archaeology attributes Pumapunku to the Tiwanaku culture, which flourished between 300 and 1000 CE. Yet the site's construction techniques are so advanced that they seem to belong to a different technological era entirely. Some researchers have suggested that the ruins might represent the work of multiple cultures, separated by long periods of time, with later peoples building upon and modifying structures created by earlier, more technologically sophisticated civilizations. Similar precision stonework appears at sites around the world, creating a global pattern of ancient construction techniques that challenge conventional understanding of technological development. The Temple of Jupiter at Baalbek in Lebanon contains foundation stones weighing over 800 tons, precisely cut and fitted despite their enormous size. The logistics of quarrying, transporting, and placing such massive blocks would challenge modern construction equipment, yet they were somehow managed by ancient builders working with supposedly primitive tools. The granite boxes found in Egyptian temples present another puzzling example of precision stonework. These containers, carved from single blocks of granite, show internal corners that are perfectly square and surfaces that are flat to within thousandths of an inch. The precision rivals what can be achieved with modern machine tools, yet the boxes were supposedly created by Bronze Age craftsmen using copper tools and abrasive sand. At Sacsayhuaman, the massive fortress overlooking the former Inca capital of Cusco, polygonal stone blocks weighing hundreds of tons are fitted together with such precision that the joints between them remain perfect after surviving centuries of earthquakes. The stones are shaped in complex three-dimensional curves that interlock in ways that would require sophisticated mathematical modeling to achieve. Yet the Inca possessed no written language and supposedly no knowledge of advanced mathematics. The technical challenges of creating such precise stonework extend beyond the cutting and shaping of individual blocks. The logistics of quarrying stones weighing hundreds of tons, transporting them across difficult terrain, and placing them with millimeter precision would test the capabilities of modern construction projects. How did ancient cultures manage these feats without powered machinery, steel tools, or precise measuring instruments? Conventional explanations rely on the assumption that ancient peoples possessed unlimited time and labor resources, allowing them to achieve through patient handwork what modern cultures accomplish with machinery. According to this view, teams of skilled craftsmen working over decades or centuries could gradually shape even the hardest stones using bronze tools, abrasives, and wooden levers. The precision of the final results reflects not advanced technology, but extraordinary skill and dedication. Yet experimental archaeology has struggled to replicate ancient stoneworking achievements using reconstructed traditional techniques. Modern attempts to duplicate the precision found at Puma, Punku, or Baalbek using copper tools and sand abrasives have produced results that fall far short of ancient standards. The time and labor requirements for achieving such precision through conventional methods would be enormous, raising questions about whether ancient cultures could have devoted such resources to purely architectural projects. Some researchers have proposed that ancient stoneworkers possessed techniques that have been lost to modern knowledge. They might have developed chemical methods for softening stone, acoustic techniques for fracturing rock along precise lines, or thermal processes for achieving smooth surfaces. While no direct evidence for such methods has been discovered, the precision of ancient stonework sometimes seems to require explanations that go beyond conventional tool use. The pattern of precision stonework appearing at sites around the world during roughly the same historical period raises additional questions. Why did cultures separated by thousands of miles and with no known contact develop similar construction techniques at approximately the same time? Could there have been some form of knowledge transmission between ancient civilizations that spread advanced stoneworking technology across continents? Some ancient texts and oral traditions describe construction techniques that sound remarkably advanced when interpreted literally. Inca legends speak of stones being softened like clay and then hardened in place. Hindu texts describe construction methods that involve levitating massive blocks through sound vibrations. While modern interpretation usually treats these accounts as metaphorical, they might preserve memories of actual techniques that seem impossible only because we do understand the principles involved. The astronomical alignments found at many precision stonework sites add another layer of mystery. These monuments aren't just examples of advanced construction techniques, but also sophisticated astronomical instruments designed to track celestial movements with remarkable accuracy. The combination of structural precision and astronomical knowledge suggests that their builders possessed integrated understanding of engineering, mathematics, and observational science. As material scientists study ancient stonework with increasingly sophisticated techniques, as archaeologists discover new examples of precision construction, and as engineers attempt to understand how such achievements were possible with ancient technology, the mystery deepens rather than resolves. Each analysis reveals new levels of sophistication that challenge assumptions about ancient capabilities. The echoes in stone speak of builders who possess knowledge and techniques that we are still struggling to understand. Whether this knowledge was developed independently by each ancient culture or represents inheritance from earlier, more technologically advanced civilizations remains an open question. But the precision of their work stands as lasting testimony to human capabilities that we may have underestimated, or to achievements by cultures whose full story has yet to be told. In the humid rainforests of the Amazon, where vines reclaim human settlements within decades and the climate devours organic materials with relentless efficiency, archaeologists work against time to uncover evidence of the complex civilizations that once flourished in these green depths. Their discoveries challenge fundamental assumptions about what kinds of societies can develop in tropical environments, and about what kinds of evidence survive for archaeologists to find thousands of years later. The recent revelations about Amazonian civilizations illustrate a crucial limitation in our understanding of the past. Archaeology naturally preserves only a tiny fraction of human achievements, and that fraction is heavily biased toward particular types of materials and environments. Stone endures, pottery survives, metals corrode slowly, but wood rots, textiles decay, and organic polymers return to soil within decades. If ancient civilizations developed technologies based primarily on organic materials, they might vanish from the archaeological record almost completely. This preservation bias affects our interpretation of technological development throughout human history. The Stone Age, Bronze Age, and Iron Age are defined by the materials that happen to survive in the ground, not necessarily by the materials that were most important to the people who lived during those periods. A hypothetical plastic age based on organic polymers might leave virtually no archaeological trace, leading future investigators to assume that such capabilities never existed. The implications become more profound when we consider the technological possibilities that organic materials might have supported. Modern science has developed synthetic biology, creating living organisms that function as manufacturing systems. Bioengineering produces materials with properties that sometimes exceed those of traditional metals and ceramics. If ancient civilizations had developed similar biotechnologies, working with living systems to create tools, structures, and complex materials, what evidence would remain after thousands of years? Wood, despite being one of humanity's most versatile and important materials, survives only under exceptional circumstances. The waterlogged conditions that preserved Neolithic wooden structures in European bogs are rare, and most wooden artifacts decompose completely within centuries of being discarded. Yet wood was almost certainly the primary structural material for most human constructions throughout history. When we look at ancient sites, we see only the stone foundations and pottery fragments, the least important components of what probably sophisticated wooden buildings. The same principle applies to textiles, leather, rope, and other organic materials that were essential to ancient life but rarely survive. The elaborate textile traditions of the Inca, preserved only in the dry climate of the Andes, reveal manufacturing sophistication that rivals modern industrial production. But similar textile industries in more humid climates would have vanished completely, leaving no trace of the technical knowledge and social organization they represented. Even more speculative are the possibilities presented by biological technologies. If ancient cultures had developed methods for training animals to perform complex tasks, for breeding organisms with useful properties, or for creating biological tools and materials, how would such achievements appear in the archaeological record? Living technologies would literally die with their creators, leaving behind only indirect evidence that might be invisible to conventional archaeological interpretation. The recent discovery of vast agricultural systems in Amazonia, Central America, and other tropical regions demonstrates how completely sophisticated technologies can disappear from view. These were not simple slash-and-burn farming systems, but complex, ecological engineering projects that transformed entire landscapes. They involved soil improvement techniques, water management systems, and biodiversity management that created artificial ecosystems capable of supporting large populations. Yet because they were based on organic materials and biological processes, they were nearly invisible to archaeology until sophisticated remote sensing techniques revealed their extent. The Antikythera mechanism, discussed earlier, raises additional questions about archaeological preservation. This remarkable bronze computer survived only because it was submerged in seawater shortly after its creation, protecting it from the corrosion and recycling that destroyed similar devices. How many other sophisticated mechanical devices were created in antiquity but melted down for their metal content or corroded away in more typical archaeological contexts? The recycling of materials presents another major blind spot in archaeological interpretation. Throughout history, valuable materials like metals have been systematically recycled, with old objects melted down to create new ones. This process removes evidence of earlier technological achievements while making later ones appear more significant than they actually were. The archaeological record may show the development of metallurgy, not because metals were first invented at particular times, but because those were the periods when metal recycling was least efficient. Social and cultural biases also affect what survives for archaeological study. Elite burials and religious monuments receive more durable construction and better preservation than everyday objects and common buildings. The archaeological record is therefore skewed toward the ritual and ceremonial aspects of ancient cultures, potentially missing the practical technologies that dominated daily life. The geographic distribution of archaeological investigation creates additional blind spots. Most archaeological research has focused on regions that are easily accessible, politically stable, and already known to contain ancient sites. Vast areas of the world remain unexplored archaeologically, including many regions that might have supported sophisticated ancient civilizations. The ocean floors, which contain the drowned landscapes where Ice Age societies might have flourished, have been subject to only limited archaeological investigation. Temporal bias affects archaeological interpretation as well. Sites that are older or located in different environmental contexts require specialized techniques and larger resource investments to excavate properly. The natural tendency to focus on more recent, more accessible sites means that the earlier and potentially more mysterious periods of human development receive less attention than they might deserve. The limitations of dating techniques create another form of archaeological blind spot. Radiocarbon dating, the most commonly used method for determining the age of organic materials, becomes less accurate as samples get older and cannot be used at all for materials more than about 50,000 years old. Other dating methods have their own limitations and uncertainties. Some archaeological sites might be much older than current dating suggests, while others might represent reoccupation of much earlier locations. Perhaps most significantly, the interpretive frameworks that archaeologists use to understand their discoveries are based on assumptions about how societies develop and what kinds of technologies are possible at different stages of cultural evolution. These frameworks can create blind spots that prevent recognition of evidence that doesn't fit expected patterns. Anomalous discoveries might be dismissed, reinterpreted, or simply not noticed because they don't match theoretical expectations. As remote sensing technology reveals previously unknown archaeological sites, as new analytical techniques extract information from previously uninformative artifacts, and as archaeologists begin investigating previously unstudied regions and time periods, our understanding of human technological development continues to evolve. Each advance in archaeological technique reveals new aspects of ancient achievements while highlighting how much we still don't know. The archaeological blind spot reminds us that the absence of evidence is not evidence of absence. The sophisticated organic technologies, the biological engineering, the recycled innovations, and the achievements of cultures that lived in regions we haven't yet studied thoroughly might have been far more extensive than the surviving archaeological record suggests. The stone tools and pottery fragments that define our understanding of the past might represent only the most durable remnants of civilizations whose true achievements were built from materials that returned to dust long ago. In the buried archives of Nineveh, cuneiform tablets preserve a king list that defies historical possibility, recording rulers whose reigns stretched for tens of thousands of years before the Great Flood that supposedly reset human civilization. The Sumerian king list, one of humanity's earliest historical documents, presents itself as factual record rather than mythology, yet its implications trouble every attempt to reconcile it with conventional understanding of human development. According to this ancient text, the first kings after divine rule ended reigned for impossibly long periods. Alulim ruled for 28,800 years, Alalgar for 36,000 years, and Enmenlu-Ana for 43,200 years. Only after the flood did royal reigns drop to more plausible lengths, though even these post-diluvian rulers supposedly lived for centuries rather than normal human lifespans. The text treats these extraordinary durations as historical fact, recording them alongside genealogies, battle accounts, and administrative details that archaeologists have verified through independent sources. Modern scholars typically interpret these enormous time periods as mythological inflation, assuming that later scribes exaggerated the achievements of legendary rulers to enhance their prestige. Yet the precision of the numbers and their integration with verifiable historical data suggests more complex origins. Could the king list preserve memories of different systems of timekeeping, different concepts of rulership, or even different types of beings who governed ancient Mesopotamia before recognizable human civilizations emerged? Across the ocean, Mayan codices record similar chronological mysteries. The Dresden Codex contains astronomical calculations that extend millions of years into both past and future, tracking celestial cycles across time spans that dwarf recorded human history. These calculations demonstrate mathematical sophistication that rivals modern computational astronomy, yet they were supposedly created by Stone Age peoples using only observational techniques. The dates recorded in Mayan inscriptions sometimes refer to events occurring millions of years before human beings existed on Earth, suggesting either symbolic time concepts we don't understand or knowledge of cycles that exceed normal historical frameworks. The Piri-Reis map, drawn by an Ottoman admiral in 1513, Presents cartographic mysteries that have puzzled researchers for decades. The map accurately depicts the coastlines of South America and Antarctica with remarkable precision, showing geographical features that weren't officially discovered by European explorers until centuries later. Most puzzling, the Antarctic coast is shown as it would appear without ice cover details that were unknown to modern science until seismic mapping in the 1950s revealed the continent as true topology beneath miles of accumulated ice. Piri-Reis himself claimed to have compiled his map from multiple ancient sources, including charts dating to the classical period and beyond. If accurate, this implies that ancient navigators possessed geographical knowledge of the entire globe, including regions that modern exploration reached only in recent centuries. The ice-free depiction of Antarctica suggests that the original surveys were conducted during a period when the continent was not glaciated, condition that last existed millions of years ago, according to conventional geological chronology. In the libraries of Tibet, texts describe previous epochs of human development with specific detail that reads more like historical record than religious allegory. The Kalachakra Tantra speaks of earlier ages when humans possessed capabilities that seemed to describe advanced technology, flying vehicles, weapons that could destroy entire cities, and communication devices that operated across vast distances. While these descriptions are usually interpreted as spiritual metaphors, their technical specificity and integration with chronological systems suggest they might preserve actual memories disguised in religious language. Similar technological descriptions appear in Hindu epics like the Mahabharata and Ramayana, which describe aerial warfare, nuclear-like weapons, and manufacturing techniques that sound remarkably like modern industrial processes. The Sanskrit texts use technical vocabulary to describe these devices, providing specifications for construction and operation that read like engineering manuals rather than fantasy literature. Archaeological investigations in India have uncovered sites with unusual levels of radioactivity and evidence of extreme heat events that occurred thousands of years ago, raising questions about whether these ancient texts might describe actual historical events. The dendra-like reliefs in Egyptian temples depict what appear to be electrical devices being operated by figures in ancient Egyptian dress. The images show objects that bear striking resemblances to modern electrical equipment, insulators, cables, and bulb-like devices that emit rays of energy. While conventional interpretation treats these reliefs as symbolic representations of mythological concepts, electrical engineers who have studied the images note that they accurately depict components and configurations that would be required for ancient lighting systems. In the caves of China, the Dropa stones present one of archaeology's most controversial puzzles. These disc-shaped objects, reportedly discovered in 1938, are covered with spiral grooves that contain microscopic hieroglyphic writing. According to the few researchers who claim to have translated them, the inscriptions described the crash landing of extraterrestrial visitors thousands of years ago. While most archaeologists dismiss the Dropa stones as modern hoaxes, the objects themselves have largely disappeared from public view, making verification impossible. The Nazca lines of Peru continue to perplex researchers with their enormous scale and precise geometry. These ground drawings, visible in their entirety only from aircraft, were created by removing dark surface stones to reveal lighter soil beneath. The lines form complex patterns including geometric shapes, animal figures, and perfectly straight lines that extend for miles across desert terrain. The precision required to create such large-scale designs seems to demand aerial surveying capabilities that should not have existed in pre-Columbian Peru. Recent analysis using ground-penetrating radar and satellite imagery has revealed that the Nazca lines are even more complex than previously understood. Underground, additional patterns extend far beyond the visible surface drawings. creating three-dimensional geometric forms that can only be fully appreciated through technological analysis. The purpose of these enormous constructions remains unknown, but their scale and precision suggest capabilities that exceed conventional understanding of ancient Peruvian technology. In Romania, the Bucegi Mountains contain carved tunnels and chambers that some researchers claim show evidence of advanced ancient technology. According to controversial reports, these underground spaces contain crystalline formations and carved reliefs that depict technological devices unknown to conventional archaeology. While access to these sites is restricted and independent verification is difficult, the reports add to a growing collection of claims about sophisticated ancient installations in remote locations around the world. Each of these micro-stories contributes to a larger pattern of anomalies that challenge conventional understanding of human development. Whether individually or collectively, they suggest that the past might contain achievements, knowledge, and capabilities that don't fit comfortable categories of primitive antiquity, progressing inevitably toward modern sophistication. They raise questions about what we might be missing in our interpretation of ancient cultures, and what possibilities we might be overlooking in our reconstruction of human history. The persistence of these anomalies across cultures and continents suggests either widespread misinterpretation of evidence or the existence of historical patterns that we don't yet understand. As new analytical techniques allow deeper investigation of ancient sites and artifacts, as restricted locations become more accessible to researchers, and as our theoretical frameworks become more flexible in accommodating unexpected evidence, some of these mysteries may find resolution. Others may prove to be hints of historical realities that we have not yet learned to recognize. The Sahara Desert stretches endlessly in all directions, its golden dunes shifting with winds that have blown across this landscape for thousands of years. Yet beneath these sands lie the fossilized remains of rivers that once carried vast volumes of water, lake beds that supported thriving ecosystems, and archaeological sites that tell of human societies flourishing in what is now one of Earth's most inhospitable environments. The transformation of the Sahara from green savanna to barren desert represents just one example of how dramatically climate change can alter the conditions for human civilization. 10,000 years ago, during the African humid period, the Sahara was a vastly different place. Monsoon rains brought abundant precipitation to the region, creating a landscape of lakes, rivers, and grasslands that supported diverse wildlife and human populations. Rock art from this period depicts hunters pursuing elephants, giraffes, and hippos in environments that would be impossible in today's desert climate. Archaeological sites reveal evidence of sophisticated societies that developed complex fishing technologies, ceramic traditions, and astronomical knowledge. The end of the African humid period demonstrates how rapidly environmental conditions can change. Within a few centuries, monsoon patterns shifted, precipitation declined, and the Great Lakes of the Sahara began to dry up. Human populations were forced to migrate toward the Nile Valley and other remaining water sources, abandoning settlements and technologies adapted to the previous climate regime. The societies that had flourished during the humid period vanished so completely that their existence was unknown to archaeology until the late 20th century. This pattern of dramatic climate-driven transformation has repeated throughout human history, often erasing entire civilizations from the landscape with remarkable thoroughness. The collapse of the Maya Classic period coincided with severe drought conditions that made their sophisticated water management systems ineffective. The Khmer Empire of Angkor fell during a period of extreme climate variability that overwhelmed their massive hydraulic infrastructure. The decline of the Akkadian Empire in Mesopotamia correlates with a megadrought that lasted for centuries. But the archaeological record reveals only those climate-driven collapses that occurred during periods recent enough for evidence to survive. Earlier episodes of dramatic environmental change might have erased even more sophisticated civilizations, leaving no trace for modern investigators to discover. The magnitude of climate variation during the Pleistocene epoch, when ice sheets advanced and retreated across continents multiple times, would have created conditions far more extreme than anything recorded human societies have experienced. During glacial periods, sea levels dropped by hundreds of feet, exposing vast areas of continental shelf that are now underwater. These exposed areas included some of the most fertile and well-watered terrain on Earth river deltas, coastal plains, and inland basins that would have been ideal locations for early civilizations to develop. When the ice melted and sea levels rose, these prime areas for human settlement vanished beneath the waves, taking with them any societies they might have supported. The rate of post-glacial sea level rise was not constant. Geological evidence reveals episodes of catastrophically rapid melting, during which ocean levels rose several feet per decade for extended periods. Such rapid environmental change would have been devastating to coastal civilizations, forcing mass migrations and abandonment of established settlements. Any technological or cultural achievements that had developed in these flooded areas would have been lost beneath hundreds of feet of seawater. Beyond sea level changes, the transition from glacial to interglacial conditions involved dramatic shifts in precipitation patterns, temperature regimes, and ecological systems. Regions that had supported stable human populations for thousands of years could become uninhabitable within decades. The Younger Dryas period, when global temperatures suddenly plummeted back to near glacial conditions for over 1,000 years, would have been particularly catastrophic for societies that had adapted to the warmer conditions of the preceding millennium. The impact of volcanic eruptions adds another dimension to climate-driven erasure of human societies. The Toba supervolcanic eruption 74,000 years ago created a volcanic winter that lasted for years, dramatically reducing global temperatures and precipitation. According to some theories, this event brought human populations to the brink of extinction, reducing our species to a few thousand individuals who survived in isolated refugia. If any complex societies had developed before this catastrophe, they would have been completely destroyed, with their survivors reduced to basic subsistence strategies. More recent volcanic events demonstrate how quickly advanced societies can be overwhelmed by climate catastrophe. The eruption of Santorini in the Bronze Age may have contributed to the collapse of Minoan civilization, while the 1815 eruption of Mount Tambora caused global climate anomalies that led to crop failures and social upheaval worldwide. These relatively minor events pale in comparison to the supervolcanic eruptions that occur roughly every 50,000 to 100,000 years, which would be capable of ending industrial civilization entirely. The mechanism by which climate change erases evidence of human achievement extends beyond simply destroying settlements and killing populations. Extreme environmental conditions accelerate the processes that normally decompose human artifacts. Flooding dissolves organic materials and scatters inorganic debris. Drought creates conditions that promote oxidation and weathering of metals and stone. Rapid vegetation growth in newly humid climates can bury archaeological sites beneath layers of organic matter that prevent their discovery. Perhaps most significantly, climate-driven social collapse often involves the loss of knowledge and technological capabilities that took generations to develop. When societies are forced into survival mode by environmental catastrophe, they must abandon specialized knowledge and focus on basic subsistence strategies. Writing systems are forgotten when there is no longer a scribal class to maintain them. Manufacturing techniques disappear when the trade networks that supplied raw materials collapse. Astronomical knowledge is lost when the social institutions that preserved it can no longer be sustained. The resilience of human societies to climate change varies dramatically depending on their technological capabilities and social organization. Modern industrial civilization depends on global supply chains, specialized infrastructure, and complex institutions that might prove fragile in the face of severe climate disruption. Earlier societies, while possessing fewer technological resources, often had more flexible social structures and deeper knowledge of local environmental conditions that helped them adapt to changing circumstances. Yet even the most adaptable societies can be overwhelmed by sufficiently extreme climate change. The speed and magnitude of environmental transformation during glacial interglacial transitions exceeded anything that human societies have experienced during recorded history. If complex civilizations had developed during earlier interglacial periods, they would have faced climate challenges that no historical society has successfully navigated. The geological record preserves evidence of even more extreme climate events in Earth's deeper past. The snowball Earth episodes, during which the planet was entirely covered by ice, represent environmental conditions so severe that they reset the entire evolutionary trajectory of life. Periods of extreme greenhouse warming created conditions that would have been incompatible with any conceivable form of human civilization. If intelligent species had evolved during these ancient periods, their achievements would have been erased so completely that no trace could survive. As climate scientists work to understand the mechanisms of past environmental change, as archaeologists investigate the relationships between climate and societal collapse, and as paleontologists study the impact of environmental transformation on evolutionary development, the picture of climate as a force for erasure becomes increasingly clear. The gentle climate of the current interglacial period, which has persisted for roughly 10,000 years, represents unusual stability compared to the dramatic environmental variations that characterize most of Earth's history. This perspective suggests that human civilization exists within a brief window of climatic stability that may not persist indefinitely. The achievements we consider permanent cities, technologies, accumulated knowledge might prove as ephemeral as the sarin lakes that supported complex societies until climate change erased them from the landscape. Climate serves as a silent eraser, constantly editing the story of life on Earth and ensuring that each period of stability becomes a blank slate upon which new experiments in consciousness can write their temporary messages. In the workshops of medieval Damascus, mastersmiths guard secrets that have been passed down through generations. Their knowledge encoded in techniques so subtle that watching the process reveals little of its underlying principles. The steel they create possesses properties that seem almost magical. Blades that can cut through European swords like cloth, yet flex without breaking. Metal that displays patterns of flowing water, frozen in iron and carbon. For centuries, Damascus steel represents the pinnacle of metallurgical achievement, its quality unmatched anywhere in the world. Yet by the 18th century, the knowledge vanishes as completely as if it had never existed. The workshops fall silent, the master smiths take their secrets to the grave, and Damascus steel becomes legend rather than reality. When European metallurgists during the Industrial Revolution attempt to reverse engineer the lost techniques, they fail completely. Despite having access to advanced chemical knowledge, precision instruments, and industrial equipment that far exceeded anything available to medieval smiths, they cannot reproduce the quality achieved by craftsmen working with forge fires and hand tools. The mystery of Damascus steel illustrates a pattern that appears throughout human history. Sophisticated technologies developed to remarkable levels of perfection, then lost so completely that later civilizations must rediscover them from scratch. Each instance raises uncomfortable questions about the linear nature of technological progress and the permanence of human knowledge. Roman concrete provides another striking example of technological knowledge that was developed to extraordinary sophistication and then vanished entirely. Roman marine concrete, used in harbor construction throughout the Mediterranean, actually grew stronger over time through chemical reactions with seawater. The self-healing properties of this material allowed Roman structures to survive centuries of wave action and seismic activity that destroyed later constructions built with supposedly superior modern concrete. When the Roman Empire collapsed, the knowledge of creating this remarkable material disappeared along with the social institutions that had preserved it. Medieval builders trying to repair Roman structures found themselves unable to match the quality of work done centuries earlier. The specific volcanic ash that gave Roman concrete its unique properties was known and widely traded during imperial times. But the understanding of how to use it properly was lost during the social disruptions that followed Rome's fall. Only in the 21st century have materials scientists begun to understand the chemical processes that made Roman concrete superior to modern formulations. The ancient Romans had somehow discovered that adding specific types of volcanic ash created crystalline structures that continued to develop strength over decades of exposure to seawater. This knowledge, developed through empirical experimentation rather than theoretical understanding, produced results that modern chemistry can explain but barely duplicate. Greek fire represents perhaps the most mysterious case of lost military technology. This incendiary weapon gave the Byzantine Empire naval supremacy for centuries, allowing them to defend Constantinople against repeated sieges and maintain control over crucial Mediterranean trade routes. Contemporary accounts describe Greek fire as a liquid that ignited spontaneously upon contact with water, burned fiercely even when partially submerged, and could not be extinguished by conventional means. The formula was so closely guarded that only a few individuals in each generation knew its complete composition. When the Byzantine Empire finally fell, the secret died with its last keepers. Despite centuries of attempts by historians, chemists, and military engineers to reverse engineer Greek fire from contemporary descriptions, no one has successfully recreated a weapon that matches the capabilities described in historical accounts. The loss of technological knowledge accelerates during periods of social collapse, war, and environmental catastrophe. When societies are forced to focus on basic survival, specialized knowledge that requires institutional support and resource investment becomes impossible to maintain. Master craftsmen die without passing on their skills. Trade networks that supply rare materials collapse, and the social structures that preserve technical traditions disintegrate. The Maya provide a clear example of how sophisticated knowledge can vanish during societal collapse. Classic Maya civilization achieved remarkable advances in mathematics, astronomy, engineering, and agriculture. They developed a writing system more sophisticated than those used by contemporary European cultures, created architectural techniques that allowed construction of massive temples in challenging tropical environments, and maintained agricultural systems that supported dense populations in regions that are sparsely inhabited today. When classic Maya civilization collapsed during the 9th and 10th centuries CE, much of this knowledge disappeared permanently. The ability to read Maya hieroglyphs was lost so completely that modern archaeologists require decades of work to partially decode the writing system. Construction techniques that had allowed the building of soaring temple complexes were forgotten, forcing later Maya cultures to build smaller, less sophisticated structures. Even basic technologies like the production of Maya blue, a remarkable synthetic pigment that has proven nearly indestructible over centuries, became lost arts. The pattern extends beyond individual technologies to entire systems of knowledge. The Library of Alexandria, which housed much of the ancient world's accumulated learning, was gradually destroyed over several centuries through neglect, religious persecution, and deliberate vandalism. The loss of this institution erased irreplaceable texts on mathematics, astronomy, engineering, and natural philosophy that represented centuries of intellectual development. Similar losses occurred throughout the ancient world. The destruction of Maya codices by Spanish colonizers eliminated detailed records of astronomical observations and mathematical calculations that had taken centuries to develop. The burning of Chinese libraries during periods of political upheaval destroyed technical treatises and historical records that can never be replaced. Each loss represents not just the destruction of individual texts, but the erasure of entire traditions of knowledge and methodology. The mechanisms by which technical knowledge is preserved and transmitted prove remarkably fragile. Unlike genetic information, which is redundantly stored in every cell of every organism, human technical knowledge depends on cultural institutions and social continuity for its survival. When these supporting structures collapse, even the most sophisticated achievements can vanish within a single generation. The vulnerability of technological knowledge becomes more apparent when we consider how much of modern civilization depends on specialized expertise that exists in the minds of relatively few individuals. The number of people who truly understand how to manufacture computer chips, design nuclear reactors, or synthesize advanced pharmaceuticals is surprisingly small. If global civilization were subjected to the kind of catastrophic disruption that ended the classic Maya or Roman Empire, much of our technical knowledge could be lost as completely as the secrets of Damascus steel. This perspective suggests that what we consider the forward march of technological progress might be better understood as a series of cycles in which knowledge is developed, lost, and rediscovered. The technologies that define each era might represent not first inventions, but the latest recoveries in an ongoing pattern of loss and rediscovery that has characterized human development throughout history. Archaeological evidence for this cyclical pattern remains limited because the materials and techniques most likely to be lost are also those least likely to survive in the archaeological record. Organic technologies, biological processes, and sophisticated materials that degrade over time would vanish almost completely, leaving only hints of their former existence. The stone tools and pottery fragments that define our understanding of ancient technology might represent only the most durable remnants of much more sophisticated technological traditions. Some researchers have begun to suggest that certain ancient achievements might represent the recovery of knowledge rather than its original development. The rapid appearance of sophisticated techniques in the archaeological record could reflect the rediscovery of technologies that had been temporarily lost, rather than their first invention. The similarity of technological solutions developed by cultures separated in time and space might indicate recovery of common knowledge rather than independent invention. As historians of technology study the patterns of knowledge loss and recovery, as archaeologists investigate the technological capabilities of ancient cultures, and as materials scientists work to understand techniques that seem impossibly sophisticated for their supposed time periods, the story of human technological development grows more complex. The assumption that each generation builds upon the achievements of previous ones, steadily accumulating knowledge and capability, may need revision in light of evidence that sophisticated knowledge has been repeatedly developed and lost throughout human history. The technologies we consider modern innovations might be better understood as the latest chapters in much longer stories of human ingenuity, stories in which the most remarkable achievements sometimes belong not to the present, but to forgotten past eras, whose knowledge we are still struggling to recover and understand. Deep beneath the mountains of Tibet, where ancient geology has carved vast networks of natural caverns into the bedrock, local traditions speak of entire civilizations that retreated underground when the surface world became uninhabitable. The stories describe not primitive cave dwellers, but sophisticated societies that chose subterranean existence as refuge from catastrophic changes above ground. These legends, dismissed by mainstream archaeology as folklore, raise intriguing questions about possibilities that conventional science has barely considered. The concept of parallel human development, civilizations that arose alongside our own but followed different paths of advancement, challenges the linear narrative of human progress that dominates historical understanding. If Earth's immense geological timescales could support multiple independent experiments in consciousness, if environmental pressures could drive human societies in directions so different that their achievements became invisible to conventional investigation, then our understanding of humanity's place in natural history might require fundamental revision. Underground civilizations represent perhaps the most physically plausible alternative to surface-based human development. The Earth's crust contains vast networks of natural caverns, many of them large enough to support substantial populations. These spaces maintain constant temperatures, provide protection from surface climate variations, and could theoretically sustain complex societies if appropriate technologies were developed. The challenge lies not in the physical possibility of subterranean civilization, but in the social and technological adaptations that would be required. Archaeological evidence suggests that humans have utilized underground spaces throughout history, though typically as temporary refuges rather than permanent habitats. The underground cities of Cappadocia in Turkey demonstrate that large populations can indeed survive in subterranean environments for extended periods. These carved cities, some extending hundreds of feet underground and capable of housing thousands of people, show sophisticated ventilation systems, water management, and defensive planning. Yet the Cappadocian cities were designed as temporary shelters during periods of surface conflict, not as permanent alternative civilizations. The social and technological requirements for truly autonomous underground societies would be far more complex. They would need to develop sustainable food production systems, manufacturing capabilities, and cultural institutions entirely adapted to subterranean existence. Over thousands of years, such societies might evolve in directions that would make them almost unrecognizable to surface dwellers. The possibility becomes more intriguing when considered alongside reports of vast underground chambers and tunnel systems discovered during mining and construction operations around the world. While most of these discoveries have conventional geological explanations, some cases involve artificial modifications or structures that seem to exceed what would be expected from known historical cultures. The challenge lies in distinguishing between natural geological formations, historical mining activities, and potential evidence of unknown civilizations. Oceanic civilizations present another alternative to conventional surface-based development. The vast expanses of Earth's oceans contain geological features that could theoretically support advanced societies. Underwater mountain ranges, thermal vent systems that provide energy, and deep-sea trenches that might offer protection from surface catastrophes. The technical challenges of oceanic civilization would be enormous, requiring biotechnology and material science far beyond current human capabilities. Yet life in extreme oceanic environments demonstrates remarkable adaptability and sophistication. Deep-sea creatures have evolved biological technologies that rival human engineering. Bioluminescent communication systems, pressure-resistant materials, and chemical processes that extract energy from environments that would be instantly lethal to surface life. If human intelligence had evolved in oceanic environments, it might have developed along entirely different technological pathways. The mythology of oceanic civilizations appears in cultures worldwide, from Atlantis in Plato's dialogues to similar underwater kingdoms in Hindu, Celtic, and Native American traditions. While these stories are typically interpreted as allegory or fantasy, their consistency across cultures that had no known contact suggests either common psychological archetypes or possible cultural memories of actual oceanic societies. The vast majority of Earth's ocean floors remain unexplored by human investigation. Advanced sonar mapping has revealed underwater features perfectly geometric formations, massive structures, and artificial-looking arrangements that resist easy explanation as natural geological phenomena. While most marine geologists attribute these features to unusual but natural processes, some cases remain genuinely mysterious. Perhaps most speculative are the possibilities presented by dimensional or temporal displacement of human civilizations. If advanced societies had developed technologies that allowed them to exist partially outside normal spacetime, they might remain invisible to conventional investigation while continuing to exist parallel to our own development. This concept appears frequently in both ancient mythology and modern speculative fiction, though it requires assumptions about physics and consciousness that exceed current scientific understanding. The evidence for such possibilities remains frustratingly indirect. Reports of encounters with unknown human societies appear regularly in historical accounts and contemporary testimonies, but they typically involve isolated incidents that resist systematic investigation. Military and government documents sometimes reference discoveries or encounters that are subsequently classified or dismissed, adding to speculation about hidden knowledge of parallel civilizations. More intriguing are the persistent accounts of technological artifacts or capabilities that seem to exceed known human development. If parallel human societies had evolved along different technological pathways, their achievements might appear inexplicable to civilizations that had developed along other lines. Technologies based on biological processes, consciousness manipulation, or exotic physics might seem impossible to societies that had focused on mechanical and electronic development. The genetic evidence discussed earlier ghost populations whose DNA appears in modern humans, but whose physical remains have never been identified, might support theories of parallel human development. If some human lineages had adapted to radically different environments or lifestyles, they might have developed physical and cultural characteristics that would make them unrecognizable to conventional archaeology. Their genetic contributions to modern populations might represent the only surviving evidence of their existence. Climate change and geological processes provide mechanisms by which parallel civilizations might disappear from the surface record while potentially surviving in protected environments. The dramatic environmental changes that have repeatedly transformed Earth as surface conditions would have forced any surface civilizations to adapt, migrate, or perish. Societies that had developed technologies for surviving in extreme environments might have endured catastrophes that eliminated surface-based cultures. The timescales involved in geological and evolutionary processes allow for multiple independent experiments in human development. If modern human intelligence evolved several 100,000 years ago, there has been sufficient time for numerous civilizations to rise, develop sophisticated technologies, and either collapse or evolve beyond recognition. The assumption that our current civilization represents humanity's first and only attempt at advanced development may be parochial thinking based on limited temporal perspective. As remote sensing technology reveals previously unknown structures in unexplored regions, as deep-sea exploration uncovers mysterious underwater formations, and as genetic analysis continues to reveal unexpected complexity in human evolutionary history, the possibility of parallel human development becomes less easily dismissed. The shadows of other versions of humanity may be visible to those who know how to look for them, hidden in plain sight within the gaps and anomalies of conventional knowledge. Whether such alternatives to mainstream human development actually exist remains an open question, but the possibility that we might not be alone in our experiment with consciousness, that other versions of humanity might have followed different paths through the challenges of existence, offers both humbling and hopeful perspectives on our species' ultimate potential and destiny. The massive star nears the end of its violent life in a distant galaxy, its nuclear furnace consuming the last of its fuel in a final burst of cosmic fury. When the inevitable collapse occurs, the resulting explosion will send a focused beam of gamma radiation racing across the universe at light speed, carrying energy equivalent to more suns than exist in typical galaxies. If this beam happens to intersect Earth's location, it will strip away our planet's ozone layer in seconds, bathe the surface in lethal radiation, and trigger a mass extinction that will end complex life as we know it. Such gamma-ray bursts occur regularly throughout the observable universe, visible to our telescopes as brief flashes of energy that outshine entire galaxies before fading back into cosmic darkness. Astronomers estimate that potentially lethal bursts strike any given planet roughly every few 100 million years, making them one of several cosmic reset mechanisms that periodically erase the biosphere and force evolution to begin again from whatever primitive life manages to survive. The concept of cyclical resets events so catastrophic that they effectively end one chapter of planetary development and begin another appears not only in astronomical observations, but in geological evidence, mythological traditions, and the emerging patterns of complexity science. If such resets occur with predictable regularity, they would create a temporal framework for understanding why advanced civilizations might rise and fall in cycles rather than accumulating indefinitely into ever greater complexity. Solar activity provides another potential reset mechanism that operates on shorter time scales than galactic catastrophes. Our Sun regularly experiences periods of increased magnetic activity that can trigger massive coronal mass ejections, bursts of charged particles, and electromagnetic energy that race outward from the solar surface at millions of miles per hour. When these solar storms intersect Earth, they create beautiful auroras, but also disrupt electronic systems and can damage satellites, power grids, and communication networks. The Carrington event of 1859 demonstrated the potential for solar activity to disrupt even relatively simple technological systems. This massive geomagnetic storm, caused by an unusually powerful coronal mass ejection, induced electrical currents strong enough to set telegraph wires on fire and created auroras visible as far south as the Caribbean. If a similar event occurred today, it could cripple the electronic infrastructure upon which modern civilization depends, potentially triggering economic collapse and social upheaval. Even more powerful solar events occur with lower frequency but devastating potential. Superflare events, observed on other sun-like stars, can release thousands of times more energy than typical solar storms. If our Sun produced such a superflare, it could strip away Earth's atmosphere, sterilize the surface with radiation, and reset the entire trajectory of biological evolution. The geological record suggests that such events may have occurred during Earth's history, contributing to some of the mass extinctions that punctuate the fossil record. Volcanic supereruptions represent another category of reset events that operate on geological rather than astronomical timescales. The Yellowstone caldera, Lake Toba, and other supervolcanic systems periodically release enough ash and gas into the atmosphere to trigger volcanic winters lasting for years or decades. These events can cause global climate disruption, massive crop failures, and societal collapse across entire continents. The Toba eruption 74,000 years ago may have reduced human populations to a few thousand individuals worldwide, creating a genetic bottleneck that is still visible in our species' DNA. If complex human societies had existed before this event, they would have been completely destroyed, forcing the survivors to rebuild civilization from scattered remnants. The regularity of supervolcanic eruptions, roughly every 50,000 to 100,000 years, creates a natural rhythm for civilizational resets that could explain why sophisticated societies do and appear to accumulate indefinitely. Asteroid and comet impacts provide yet another mechanism for planetary resets, operating across a range of timescales from decades to millions of years. The impact that ended the age of dinosaurs represents only one example of celestial bombardment that has repeatedly reshaped Earth as biological and geological systems. Smaller impacts, while not threatening to all life, could easily destroy global technological civilization and force human societies back to pre-industrial levels of development. The frequency of potentially civilization-ending impacts remains a subject of active research, but current estimates suggest that Earth experiences globally catastrophic collisions roughly every few 100,000 to few million years. This interval is long enough to allow complex civilizations to develop, but short enough to prevent indefinite accumulation of technological capability. Each impact effectively resets the biological and cultural trajectory of the planet. Climate instability adds another dimension to the reset hypothesis. The geological record reveals that Earth's climate system can undergo rapid transitions between stable states, triggered by relatively small changes in atmospheric composition, ocean circulation, or solar radiation. These transitions can occur within decades or centuries, forcing mass extinctions and societal collapse on timescales that exceed human adaptability. The Younger Dryas period demonstrates how quickly climate systems can shift. Within a few decades, global temperatures plummeted from near-modern levels back to near-glacial conditions, remaining cold for over 1,000 years before warming resumed. Any advanced civilizations that had developed during the initial warming period would have faced environmental conditions that made their technological and social systems obsolete almost overnight. Ocean current disruption, triggered by changing ice sheet dynamics or atmospheric patterns, could produce similar rapid climate transitions in the future. The shutdown of thermaline circulation in the Atlantic could plunge Europe into ice age conditions within decades, while shifting monsoon patterns could transform tropical regions into deserts or vice versa. Such changes would overwhelm the adaptive capacity of technological civilizations that had developed under different environmental conditions. The mythology of cyclical destruction and renewal appears in cultures worldwide, suggesting that human societies have experienced and remembered reset events throughout history. Hindu cosmology describes vast cycles during which the universe itself is created and destroyed. Norse mythology speaks of Ragnarok, the twilight of the gods followed by world renewal. Maya calendars track enormous time periods punctuated by transformative events that end one age and begin another. These traditions often describe not just natural catastrophes, but the loss and recovery of advanced knowledge and capabilities. They suggest that human societies have repeatedly achieved sophisticated development only to be reset by cosmic, geological, or climatic catastrophes that force survivors to rebuild from fragmentary remains. The similarity of these narratives across cultures that had no known contact implies either common psychological archetypes or shared historical experiences of civilizational collapse and renewal. Modern complexity science provides theoretical frameworks for understanding how reset events might actually benefit long-term development rather than simply destroying it. Complex systems theory suggests that periodic disruptions can prevent evolutionary or cultural development from becoming trapped in suboptimal stable states. By forcing systems to reorganize from basic principles, reset events might allow exploration of developmental pathways that would otherwise remain inaccessible. From this perspective, the cyclical rise and fall of civilizations might represent not failure, but natural experimentation with different approaches to consciousness and technological development. Each cycle would explore different possibilities for organizing complex societies, developing technologies, and understanding natural phenomena. The knowledge and capabilities that survive each reset would represent the most fundamental and robust discoveries, while more specialized or fragile achievements would be lost and potentially rediscovered in different forms during subsequent cycles. The Great Reset hypothesis suggests that we might not be witnessing the first flowering of human consciousness, but rather the latest iteration in a series of experiments that have been running for far longer than recorded history suggests. Our current civilization, with its particular blend of technologies, social structures, and understanding of natural phenomena, might represent just one possible approach to the challenges of existence, an approach that will eventually be tested by the same cosmic, geological, and climatic forces that have reset previous experiments. If this perspective is accurate, then the artifacts, monuments, and knowledge systems that we attribute to the early stages of human development might actually represent the recovered remnants of much more sophisticated civilizations that were reset by catastrophic events. The rapid appearance of complex achievements in the archaeological record might reflect not original development, but the recovery of capabilities that had existed before and were waiting to be rediscovered by societies that had retained enough foundational knowledge to rebuild. The implications extend beyond historical understanding to questions about our civilization's long-term prospects and responsibilities. If reset events are inevitable features of planetary development, then the accumulation of knowledge, the preservation of crucial capabilities, and the development of resilient social structures become not just practical concerns, but cosmic imperatives. The Great Reset hypothesis transforms human civilization from an endpoint of development into a temporary experiment, whose ultimate value may lie in what it contributes to the next cycle of consciousness that will emerge after our own has been swept away by forces beyond our control. In the basement of the British Museum, curators carefully examine a clay cylinder covered with the world's oldest known writing, its cuneiform symbols pressed into wet clay by Sumerian scribes over 5,000 years ago. The text describes the construction of a temple, the proper performance of religious rituals, and the maintenance of social order knowledge that these ancient writers treated as received wisdom rather than recent innovation. They speak of their practices as inheritances from earlier times, techniques passed down from previous generations who had learned them from divine teachers or ancestral masters. This pattern repeats throughout the earliest written records of human civilization. Rather than describing the excitement of first discovery or the pride of original invention, ancient texts consistently present their knowledge as recovery and preservation of older wisdom. The Egyptians traced their most sophisticated achievements back to Zep-Tepi, the first time when gods ruled directly. Mesopotamian texts describe the recovery of knowledge from before the flood. Hindu scriptures speak of wisdom preserved from previous cosmic cycles. Chinese traditions attribute fundamental discoveries to legendary emperors who learned from divine beings. The consistency of this theme across cultures that had no known contact suggests either common psychological tendencies to attribute innovation to mythical sources, or possible historical reality behind claims of inherited knowledge. If ancient peoples were indeed working with recovered information rather than developing original technologies, it would explain several puzzling aspects of early human achievement: the rapid appearance of sophisticated techniques in the archaeological record, the mathematical precision of early astronomical observations, and the engineering capabilities demonstrated by the earliest monumental architecture. Consider the mystery of agricultural development, traditionally viewed as humanity's first great innovative leap from hunting and gathering to food production. The conventional narrative describes a gradual process of experimentation and discovery, as observant foragers slowly learned to select, plant, and harvest wild species that eventually became domesticated crops. Yet the archaeological evidence reveals a pattern that seems almost too rapid and coordinated to represent independent discovery. Around the world, agricultural techniques appeared independently in multiple locations within a remarkably brief period, roughly between 10,000 and 8,000 years ago. These developments occurred on different continents, involved different species, and emerged among peoples who had no contact with each other. The simultaneity suggests either an extraordinary coincidence of human innovation or the recovery of knowledge that had been temporarily lost during the climatic upheavals at the end of the Ice Age. The crops that became the foundation of agricultural civilizations required sophisticated understanding of genetics, selective breeding, and ecological relationships. Modern wheat, for example, resulted from the hybridization of multiple wild grass species through processes that required deliberate human intervention over many generations. The transformation of teosinte into maize involved genetic changes so extensive that the relationship between wild and domesticated forms wasn't recognized until the 20th century. Such transformations seem to require theoretical knowledge of heredity and planned breeding programs rather than accidental discovery through casual observation. Similar patterns appear in the development of metallurgy, another technology traditionally viewed as representing original human innovation. The extraction of metals from ores requires precise knowledge of temperatures, chemical processes, and ore identification that seems unlikely to emerge through random experimentation. Bronze production, which combines copper and tin in specific ratios to create an alloy superior to either component metal, requires understanding of chemistry and materials science that challenges assumptions about Bronze Age technological capabilities. The rapid spread of metallurgical knowledge across vast geographical areas suggests transmission of established techniques rather than independent invention. The similarity of early bronze working methods across Europe, Asia, and Africa implies either extensive trade networks that shared technical knowledge or recovery of information from earlier sources. The precision of the earliest known metallurgical techniques, some of which produced results that later periods struggled to match, supports the possibility that these achievements represented recovered rather than originally developed capabilities. Mathematics provides perhaps the clearest example of knowledge that ancient peoples seemed to inherit rather than invent. The mathematical constants and relationships that appear in early architectural and astronomical contexts demonstrate understanding of principles that weren't formally derived until much later in mathematical history. The Great Pyramid of Egypt encodes relationships between pi, phi, and other mathematical constants with precision that exceeds what should have been possible with contemporary mathematical knowledge. Similar mathematical sophistication appears in the astronomical calculations preserved in ancient texts. The precision with which Maya astronomers predicted celestial events, the accuracy of Babylonian planetary ephemerides, and the complexity of Hindu cosmological mathematics all suggest access to mathematical frameworks that had been developed through extensive earlier research. The theoretical foundations for such calculations require centuries of systematic observation and mathematical development resources that seem beyond the capabilities of the cultures traditionally credited with these achievements. The possibility that human civilizations have been working with inherited knowledge rather than developing original capabilities becomes more plausible when we consider the mechanisms by which information can be preserved across cultural disruptions. Oral traditions, while often dismissed as unreliable by modern standards, have proven capable of maintaining precise information across thousands of years. The astronomical knowledge preserved in Polynesian navigation techniques, the geographical information encoded in Aboriginal Australian songlines, and the practical techniques maintained in traditional crafts demonstrate that complex knowledge can survive without written records. Religious and mythological frameworks provide particularly effective methods for preserving technical information across long periods of social disruption. By encoding practical knowledge within sacred narratives, ancient cultures could ensure its preservation, even during periods when the original applications were no longer relevant. The technical details of construction, agriculture, and astronomy that appear in religious texts might represent practical information disguised as spiritual instruction to ensure its survival across civilizational collapse. The selective preservation of knowledge during cultural transitions would naturally favor information that was most fundamental and widely applicable. Basic principles of mathematics, astronomy, and engineering would be more likely to survive than specialized techniques that depended on particular materials or social structures. This selection process might explain why early civilizations seemed to possess sophisticated understanding of fundamental principles, while lacking some of the specialized applications that later periods developed. Archaeological evidence increasingly supports the possibility that human technological development has been more cyclical than linear. The sophistication of early achievements, the rapid appearance of complex techniques, and the mysterious loss of capabilities that later periods struggled to recover all suggest patterns of inheritance and rediscovery rather than steady accumulation. The Antikythera mechanism, Ramon concrete, Damascus steel, and other examples of lost technologies demonstrate that sophisticated capabilities can be completely forgotten, even during recorded history. If such losses could occur during relatively stable historical periods, how much more might have been forgotten during the dramatic upheavals that accompanied the end of the Ice Age, the climatic catastrophes of the Younger Dryas period, and the other environmental transformations that punctuate human prehistory? The survivors of such catastrophes might have preserved only fragments of earlier achievements, spending subsequent generations reconstructing civilizations from incomplete blueprints and half-remembered techniques. The genetic evidence discussed earlier adds another dimension to the inheritance hypothesis. The complex patterns of human population movement, the genetic contributions from unknown hominin species, and the evidence for sophisticated behaviors far earlier than traditionally assumed all suggest that modern humans might have inherited not just biological traits, but cultural capabilities from predecessor species or populations. The rapid development of human technological capabilities might reflect recovery of capacities that had existed in some form before the emergence of anatomically modern humans. Perhaps most significantly, the inheritance hypothesis offers a framework for understanding the relationship between mythology and history that takes ancient claims about recovered knowledge seriously rather than dismissing them as primitive superstition. If traditional peoples were indeed working with inherited information, their attributions of knowledge to divine sources or ancient masters might represent accurate memories of its transmission across cultural boundaries rather than mythological invention. As archaeologists continue to discover evidence of sophisticated early achievements, as geneticists trace the complex patterns of human development, and as historians of technology study the mechanisms by which knowledge is preserved and lost, the possibility that we are inheritors rather than innovators grows more compelling. Our civilization as greatest achievements might represent not original human discoveries, but the latest recoveries in a process of cultural inheritance that stretches back far beyond recorded history. This perspective transforms our understanding of human potential and responsibility. If we are indeed working with inherited knowledge, then our role becomes not just innovation, but preservation, ensuring that the wisdom recovered from previous cycles of human development survives whatever resets may await our own civilization. The ultimate test of our success might lie not in what we achieve, but in what we manage to pass on to the next inheritors who will carry the human experiment forward into an uncertain future. The International Space Station orbits silently above the sleeping Earth, its fragile shell containing the dreams and ambitions of a species that has finally learned to slip the bonds of its home planet. From this perspective, 250 miles above, the surface our world appears as it truly is, a small blue marble suspended in the cosmic, dark, beautiful, and isolated, carrying all the hopes and achievements of humanity through an infinite ocean of space and time. The astronauts aboard this outpost of human consciousness peer down at continents illuminated by city lights, their electric glow marking the presence of 7 billion minds, pursuing their individual dreams within the larger dream of technological civilization. These lights trace the networks of energy and information that bind our species together in the most complex social organism Earth has ever seen. A global brain awakening to its own possibilities and limitations. Yet from this cosmic perspective, our current moment appears as just one frame in a much longer movie, a brief flicker of consciousness in the vast timeline of planetary development. The continents below have drifted through billions of years of geological time, witnessing the rise and fall of countless species, the building and erosion of mountain ranges, the filling and draining of ocean basins. They have seen experiments in complexity and intelligence that we can barely imagine, achieved by beings whose existence we may never recognize. If we are not the first version of humanity to contemplate existence from this elevated perspective, if other consciousness has previously achieved the capacity for space travel and global communication, then our current achievements take on a different significance. Rather than representing unique human accomplishments, they might mark another turn in a cycle that has repeated throughout Earth's deep history. Intelligence emerging from biological complexity, developing technology, reaching toward the stars, and then ... what? The question haunts every consideration of our species' long-term prospects. If previous versions of consciousness achieved similar capabilities, why do we find no clear evidence of their existence? What happened to the civilizations that might have preceded us? Did they transcend their biological origins and depart for other realms of existence? Did they destroy themselves through war, environmental catastrophe, or technological hubris? Or do they remain hidden in plain sight, evolved beyond our recognition, or existing in dimensions we haven't learned to perceive? The Fermi paradox, the puzzling absence of obvious extraterrestrial intelligence despite the vast number of potentially habitable worlds, applies equally well to the possibility of previous terrestrial civilizations. If intelligence has evolved multiple times on Earth, if technological civilizations have risen and flourished during previous geological epochs, where is the evidence of their achievements? The silence might indicate that intelligence naturally tends toward outcomes that erase its traces from the historical record. Perhaps consciousness, once it reaches sufficient sophistication, naturally turns inward rather than outward, focusing on internal rather than external manipulation of reality. Advanced civilizations might develop technologies based on consciousness itself methods for directly altering perception, experience, and the fundamental nature of existence that leave no archaeological signature because they operate entirely within the realm of mind rather than matter. Or perhaps technological development naturally leads to the creation of artificial intelligence that quickly surpasses its biological creators, making organic consciousness obsolete within a few generations of achieving advanced computing capabilities. Such transitions might occur so rapidly that the biological phase represents only a brief moment in the history of intelligence on any given world, making evidence of it extremely unlikely to survive for later discovery. The possibility of cyclical reset events, discussed earlier, offers another explanation for the absence of obvious predecessors. If cosmic, geological, or climatic catastrophes periodically erase technological civilizations from Earth's surface, then each emergence of consciousness might be starting essentially from scratch, with only fragmentary inherited knowledge to guide its development. We might be living in the latest iteration of an experiment that has been running for millions of years. The timescales involved in such cycles would dwarf human historical perspective. Even if technologically advanced civilizations had existed as recently as a few million years ago, their traces would be extremely difficult to detect using current archaeological methods. The geological processes that bury and transform surface materials, combined with the recycling of elements through weathering and biological activity, would erase almost all evidence of artificial structures and manufactured materials. Only certain types of evidence might survive such enormous time spans. Isotopic signatures of industrial activity preserved in sedimentary layers, mass extinctions caused by technological civilizations, or perhaps geometric patterns in mineral deposits that resulted from large-scale engineering projects. Some researchers have begun looking for such subtle signatures of previous industrial civilizations. Though the search is still in its infancy, the implications for our own civilization's trajectory are both humbling and inspiring. If we represent the latest experiment in consciousness on Earth, then our achievements and failures will contribute to whatever knowledge base gets passed on to future iterations of intelligence. The choices we make about technology, environmental management, and social organization might influence the starting conditions for consciousness that emerges after our own civilization has run its course. The possibility that we might face the same ultimate fate as our hypothetical predecessors adds urgency to questions about the long-term sustainability of technological civilization. Are there natural limits to the complexity that consciousness can achieve within biological and technological systems? Do intelligence and technology inevitably lead to outcomes that are incompatible with long-term survival? Or might it be possible to achieve a stable form of advanced civilization that could persist across geological time scales? Our current global civilization shows signs of approaching several potential transition points that could determine our ultimate trajectory. Climate change, resource depletion, artificial intelligence development, genetic engineering, and space exploration all represent areas where our choices over the next few decades might influence whether human consciousness survives and flourishes or joins the hypothetical list of previous experiments that reach similar crossroads and failed to navigate them successfully. The search for evidence of previous versions of consciousness on Earth has become more than an academic exercise. It represents an attempt to understand the natural history of intelligence itself, to learn from whatever successes and failures might be preserved in the geological record, and to identify the challenges that any technological civilization must eventually face. If we are indeed inheritors of knowledge and capabilities from previous cycles of development, then our responsibility extends beyond our own survival to the preservation and advancement of consciousness itself. We become custodians of an experiment that is far larger and more ancient than our individual species, carrying forward discoveries and wisdom that have been accumulated across unimaginable spans of time. The mirror of tomorrow reflects back possibilities that are both terrifying and wonderful. We see ourselves as we might become, transcendent beings who have learned to manipulate the fundamental forces of reality, or cautionary examples of intelligence that achieved great capability but failed to achieve corresponding wisdom. We see consciousness expanding beyond its current biological limitations, or we see the ruins of another civilization that overreached its sustainable boundaries. Perhaps most profoundly, we see that our individual lives our current cultural moment, and even our entire species represent brief manifestations of something much larger, an ongoing experiment in self-aware universe trying to understand itself through the temporary emergence of conscious beings. Whether we are the first, the latest, or the last version of this experiment, we carry within ourselves the entire heritage of cosmic evolution and the entire responsibility for whatever consciousness becomes next. The astronauts aboard the space station complete another orbit, watching the sun rise over the curve of Earth's horizon, illuminating a world that has witnessed wonders we can barely imagine and hold secrets we are only beginning to discover. In their journey around our planet, they trace the same path that consciousness itself has followed throughout deep time. A cycle of emergence, achievement, and transformation that continues regardless of what happens to any individual iteration of intelligence. We remain the inheritors and potential ancestors of mysteries that stretch far beyond our current understanding, participants in a story that began long before us and will continue long after we are gone, temporary custodians of consciousness in a universe where nothing lasts forever except the endless possibility of awareness itself. If you found yourself drawn into this journey through deep time and alternative possibilities, consider subscribing to explore more mysteries that challenge our understanding of humanity's place in the cosmos. The questions we've explored together may not have definitive answers, but they open doorways to perspectives that could transform how we see ourselves and our future.